Hello and a warm welcome to today's workshop, which marks the 8th annual gathering between the IEA and Tsinghua's Building Energy Research Centre. I'm delighted to be able to open today's workshop and moderate the first 2 sessions of the day. So for opening remarks today, we have esteemed speakers from China's National Development and Reform Commission, the IEA, and Tsinghua University. And without further ado, I'm delighted to invite Dr. Qin of the Energy Conservation Division of the Department of Resource Conservation and Environmental Protection of NDRC to give his opening remarks. Director Qin, the floor is yours.
好的，尊敬的各位领导、专家朋友们。
Honorable leaders, dear experts, ladies and gentlemen, good morning and good afternoon. After careful preparation, the 8th IEA-Tsinghua Joint Workshop is taking place today. We're gathered here with experts, professionals, and business community in this industry. And as a participant and a researcher in the field, I am very happy to be part of this meeting. And we warmly congratulate all of you on the successful opening of this meeting on September the 22nd, while attending the General Conference at the United Nations, President Xi Jinping made a pledge from China to reach carbon peaking and carbon neutrality with a very well-defined roadmap. And after that, all competent departments in China have taken this job very seriously, have carried out measures for its implementation. We have reached a number of milestones. We have just concluded the 20th CPC Party Congress, at which clear instructions are given, which also include the pathways forward to reach the target to reduce the carbon emission. This building is a very important sector in our effort to achieve carbon peaking and carbon neutrality. And last year, the Chinese central government has released a document that outlined its action to be taken by and before 2030 for carbon peaking and carbon neutrality. And altogether, 10 major measures have been outlined, and that include the building industry. And as a result of that, the Ministry of Housing and Urban Rural Construction, as well as the NDRC, have introduced the implementation measures. It seems that we have lost the feed from Mr. Qin. We can't hear him anymore, said Professor Jiang Yi, and he wonders what has happened. Probably it's because of internet connection, because we can't hear him, said Professor Jiang Yi. I wonder if it is because of internet connection.
Should we move on to the next speaker and see if we can reconnect with NDRC in a moment?
Yeah, that seems a good suggestion.
Okay, thank you then. So well, that was very inspiring. Hopefully we'll be able to come back to NDRC in a few minutes, but I'd like then to pass on to our next speaker, Dr.
No, he go back. Sorry.
Brian Motherway. He's back. Okay.
He's go back.
Okay.
No.
Director Qin, we lost you for a moment, but would you like to continue?
No.
Okay, Brian, maybe I could hand over to you. So Dr. Brian Motherway is Head of Energy Efficiency here at the IEA. Brian, if you'd like to make your opening remarks, thank you.
Thank you, Mel. And ladies and gentlemen, everybody, thank you for joining us. And I want to welcome you warmly to today's workshop, a very important one for us. And as Mel has said, this is the 8th annual workshop between the IEA and Tsinghua since we first started this series back in 2015. So let me first of all start by thanking Director Qin of the Energy Conservation Division of NDRC for his remarks and for participating and for the collaboration today. And of course to you, Professor Chang, and all of your team at Tsinghua for your efforts to help us organize today's important event. We're also very grateful to the Chinese National Institute for Standardization and our friends in the Energy Foundation China for your ongoing support. As we find ourselves in a global energy crisis, countries around the world are responding by seeking to boost investment in clean energy and accelerate their progress on energy efficiency. In the building sector, within which almost half of energy demand is used by space and water heating, governments around the world are looking at ways to reduce this demand through better energy efficiency. Here in Europe, the current crisis is spurring on actions related to more ambition on the demand side, boosting energy efficient solutions, low carbon heating, and other solutions that can help deal with the crisis. And in China, of course, we have seen great progress in the past few years to develop a leading standards program and to drive wide deployment of low carbon technologies, including heat pumps. But despite the technologies needed for space heating decarbonization being readily available and cost effective, significantly faster rates of deployment are needed to keep the building sector on a zero carbon pathway. In light of this, and in recognition of the critical decade we find ourselves in, this year's workshop, it will focus on near-term actions in the space heating sector. We hope that bringing together a range of international experts, we can stimulate an interesting and important discussion on policy, technology, and financing solutions. We're delighted to be working with NDRC and Tsinghua University, and we're delighted to be able to share this platform for exchange of best practices. And of course, we look forward to continued close collaboration and cooperation this year and in future years. I also want to especially thank Director Chin and NDRC for their continued engagement with us, not least in the Energy Efficiency Hub, another important global forum enabling government-to-government knowledge exchange and collaboration on energy efficiency topics in a number of sectors. And again, let me close by thanking everybody who is joining us today, and we all look forward to learning from the presentations and discussions during the workshop. Thank you.
Thank you very much, Brian. Thanks for those welcoming remarks and for thanking all of our colleagues, of course, for putting this workshop together with us. And now, and by last but by no means least, I'd like to invite our co-host, a long-term partner, Director Jiang of the Building Energy Research Center at Tsinghua University. Director Jiang, the floor is yours.
Okay, thank you. 尊敬的 Brian Musway 博士跟 IEA 的诸位
Honorable Dr. Brian Motherway, dear colleagues, officials from the IEA, Mr. Qin Kun and colleagues from the NDRC, dear experts from both China and abroad, dear participants, dear guests, dear officials, ladies and gentlemen, good afternoon. First of all, thank you for being here at the 8th IEA-Tsinghua Joint Workshop. As has been said, this is already the 8th joint workshop between the IEA and Tsinghua. It first started in 2015 when the new Director General of IEA made China as his first visit after his inauguration, and while he was in Tsinghua University, he reaffirmed efforts to establish a relationship of a long-term cooperation with Tsinghua, and under that framework, we agree to hold 1 or 2 workshops on the annual basis to exchange views on topics of common interest. And ever since then, we have organized 8 sessions that also included today's session that we're having here today. So we talk about the heating system, low carbon development in the urban area, especially in the building sector, along with many other topics. For those sessions, we invited over experts from Europe, the US, Japan, and Asia, and exchange in-depth views with each other. And I think those discussions are very meaningful because that help us make our share of contribution to low carbon development in the urban areas across the world. At present, human beings is at a critical time point in our energy revolution. So now the question is, what do we do to make sure that we go from fossil fuel-based energy consumption pattern to a new path of development characterized by zero carbon emission. I think this is a major transformation, arguably one of the most important challenges in human history that has the potential to change the way energy is used over the past 200 years since the first industrial revolution, so that we can embark on the path of a sustainable development in the energy sector. If we do a very good job with it, we are making our contribution to not just climate issues, energy issues, but also very importantly, energy security and environmental pollution, in particular, air pollution. Because that way we will have a better future as human beings. But in order to get there, efforts are needed in the energy sector from production and then every step of the way towards the last step, and that also requires the transformation of energy system both in the urban and rural area, which is also a very important topic that we are going to discuss here at this workshop. And this platform, the meeting provides us with a platform to exchange views, which in turn will help all countries to reform and transform their energy system through our policy recommendations. And through this workshop, hopefully we will also offer insights to what kind of mechanism can be introduced to support country in this transition. Finally, thanks to experts from the IEA, the NDRC, thank you to all the experts from multiple sectors, both in China and abroad. Hopefully, like the previous 7 editions, this workshop is also going to be very productive. Perhaps we can even do better with this edition, because that way we'll be able to work together to jointly contribute to the great cause that is known as the energy transformation in urban and rural areas, so that we can reach our sustainability targets. Thank you. That is from me.
Thank you so much, Professor Jiang. And I agree with you here. Let's make this the most successful of our workshops so far. It's great to build on previous experience, and it's a great topic, and it's a very timely topic. I just wanted a final check to see whether we still have NDRC with us. And if not, it doesn't seem so.
在线，大家听得见吗？
OK，好了，好了。
Yes, I am here. Can you hear me?
Yes, we can hear you well.
Yes.
Thank you very much.
非常抱歉，非常抱歉，刚
I
才
am terribly sorry for that. I had an internet connection problem, so I was cut off in the middle of my speech. I was talking about the policy framework for the decarbonization of the building sector, and I will now talk about some of the progress we have been achieved. In 2020, about 200 billion new floor area was added for green buildings. That's about 84% of the total floor area in countryside and the cities, and about 1.7 billion floor area has been renovated. And also, we have over 10 million floor area of ultra low energy consumption, and also about 5.6 billion square meters of the floor area using the solar power. We believe in the best practices from others, and in our efforts, we believe that we need a mutually beneficial partnership so as to create a synergy for decarbonization and also green development. I understand that this workshop is an important platform that brings together stakeholders from the government and the research community. This workshop has been held for 8 times and has played such an important role in putting the resources and also in forging consensus. I look forward to a further discussion, a more productive discussion to talk about the key technologies and also the policy choices out there for reducing the emission from the building sector and put our wisdom together to this end. Thank you.
Thank you so much, Director Jin, and thank you for the leadership that China is showing, both in the net zero pathways that you've established, but in particular on energy efficiency, which has been very impressive over the last couple of decades. And we hope to build on that and share with others as we go forward. So before we go to the next session, could I please ask all participants to turn on their cameras so that we can take a photograph? And Etienne, maybe you could tell us when you're done. Is that okay?
No, we'll just wait for a couple more to open their cameras. See, maybe Rafa, Hung Yijiao, and Mr. Sun.
So just to say again, if everybody could turn on their cameras, we'd just like to take a photograph before we move on. Thank you. So in the interest of time, we'll move on to the next session. So thank you everybody in that opening session. Very inspiring, a great way of setting the scene for today's workshop. What we want to do now in this next session, in this more detailed area, is look at the near-term outlook for the building sector. Look at opportunities, challenges, and pathways for delivering emissions reductions and efficiency gains between now and 2030. So we have an excellent lineup of speakers from IEA-Tsinghua, the Danish Energy Agency, the Building Research Institute of Japan, who will all be providing a different range of perspectives on this very important problem that is really timely at the moment because of the energy crisis we find ourselves in. Now, on my agenda, Connor, I was going to Chiara and Raphael, but we have Professor Zhang's presentation up.
郑老师，您应该是下一个还是这个？
这个吧，不是吗？下一个吗？
应该是您是下一个。
Oh, sorry.
Professor Zhang,
Okay, so we're going to go first to Chiara Del Mastro and Rafael Martinez Gordon, who are energy analysts here at the IEA, and they're going to set the scene for some information from the IEA. Sorry, Professor Zhang, for IEA's pathways for delivering zero carbon ready buildings by 2030. So I'll hand over to my colleagues, Chiara and Rafael.
Thanks, Mel. Good morning or good afternoon to all. In this presentation, we will go through some of the current status for buildings, energy and emissions, and also looking at some of the key measures over this decade to put buildings on track to the path to net zero emissions, and in particular focusing on heating. If we move to the next slide, we can see that in 2021, the operation of buildings accounted for about 30% of global final energy consumption and 27% of total energy sector emissions. And following the easing of COVID-19 restriction, both energy consumption and emissions rebounded to above 2019 values, a record high increase. Direct emission increased in both advanced and emerging economies, but to highlight particular growth in natural gas demand in emerging economies. And in terms of energy demand by end use, we notice an increase across all buildings and uses, but particularly to highlight an increase of space cooling demand following the many heat waves. If we go to the next slide, we've seen in recent years several energy efficiency policies which are in place in the building sector and also the power sector that continues to decarbonize. However, we see that the rising demand for energy services in buildings is outpacing energy efficiency and decarbonization gains. And this trend needs to change to be aligned with our net zero emission by 2050 scenario. Under this scenario, we are exploring possible pathway to reach net zero emission at the energy system level by 2050. And we saw that there are many opportunities there for rapidly deploying clean energy technologies in buildings, in particular supported by innovation strategies and behavioral shifts. And the current decade is really playing a critical role to put in place the policy frameworks and regulation to support this vision. A key milestone to transform the global building sector in our net zero emission scenario is to have all new and retrofitted buildings to be zero carbon ready by 2030, so by the end of this decade. The zero carbon ready concept was introduced in the net zero report that IEA published last year, and involves 4 criteria which can allow to move from zero carbon ready in 2030 to zero carbon ready by 2050. First criteria is energy efficiency and resiliency. So looking at the all building design envelope and technologies to move progressively to the best available solutions there, also taking into account that climate is changing. Second is zero emission fuels, so having a renewable production on site or relying on energy supply that will be completely decarbonized, in particular power generation and district heating. 4 criteria is flexibility, so exploiting opportunities to integrate storage solutions, using the thermal mass of the buildings, also eventually EV chargers, and exploiting the opportunities from connectivity and automations there. And 4th criteria is embodied carbon, so also targeting emissions from manufacturing buildings, construction materials. Space heating is certainly one of the most challenging end uses, and indeed is one of the is the main topic of the workshop today. Space heating is still highly relying on fossil fuels and represented almost half of energy demand for buildings in 2021, also responsible of 80% of direct CO2 emissions in the building sector. We saw progresses in recent years. The role of efficient and low carbon heating technologies continue to grow, as was highlighted in the opening, particularly in China and Europe as well. We noticed the carbon intensity reduction by 40% since 2000 for heating in buildings, and these improvements were largely thanks to more stringent buildings, energy codes, shift away from most inefficient fossil fuel boilers, but still fossil fuel meet over 60% of heating demand at the moment. The current energy crisis and also the related risk for heating energy security and affordability are really providing an unprecedented opportunities for a shift away from fossil fuel globally. And the technology needed for heating decarbonization are mostly readily available and mature, as we also heard in the opening, but we need to rapidly accelerate their deployment. And in our net zero emission by 2050 scenario, we see that the share of fossil fuels in the heating mix drops to 45% by 2040. This thanks to energy efficiency and shift to electricity, in particular heat pumps, shift to renewables, in particular solar thermal, and other low carbon, low emission heating technologies such as clean district heating. And on this, we will hear more from my colleague, Rafael Martinez Gordon. Over to you.
Thank you very much, Chiara. And hello, everyone. I hope the audio is okay. And yes, Chiara mentioned, heat pumps are one of the key elements of the rapid decarbonization that we will witness in the coming years. And actually, in the net zero emission by 2050 scenario, heat pumps meet over 20% of total heating needs by 2030. with a deployment of more than 600 million units. And these numbers reach by 2050 over 50% of space heating energy system demand, meaning a deployment of around 1.8 billion units. And that's a huge ramp up compared to the 190 million units that we estimate are deployed as of today globally. And just to put these numbers into context, in this same scenario, fossil fuel boilers don't grow beyond current levels, and by 2050 the deployment of fossil fuel boilers is marginal, being almost 0%. As I said, that's a really large scale up that is needed, but we are already seeing positive signs in main heating markets such as the US, China, European Union, or Japan. And in 2021 compared to 2020, we saw a record sales in some of these markets. For example, in Europe, we saw a 35% increase in heat pump sales, 15% increase in the US, and 13% in Japan and in China. Of course, this massive ramp up is doable, but there are some bottlenecks that can compromise that it happens, like, for example, high upfront cost of heat pumping technologies, or lack of skilled installers. So, of course, policy actions should support this deployment. The other technology that can or will play for sure a major role in this during this decade is district heating. District heating networks are very important also in the net zero emission scenario targets. And as of today, they meet around 8% of the global final heating needs in both buildings and industry, with 16 petajoules of heat produced. However, almost 90% of this district heating production comes as of today from fossil fuels. And by 2030, in order to be aligned with the net zero goals, these emissions should be at least 20% lower, via doubling the use of renewables in district heating networks, and also improving the overall efficiency of them. On top of that, district heating networks provide multiple benefits from a system perspective. For example, the use of and the recovery of waste heat, for example, from data centers, or in the future electrolyzers that could be integrated in these networks. District heating networks can also help to integrate renewables, to integrate heat pumps, either large-scale heat pumps or small-scale decentralized heat pumps, and also thermal storage systems that can support the system as a whole. And of course, the importance of district heating will be crucial in dense urban environments, and can help to deliver energy security, increasing independency from energy imports. Solar thermal technologies, either traditional solar thermal technologies or emerging technologies combining solar PV and electric heating devices, are also expected to play a major role in the coming years. And of course, they will be crucial to meet the net zero targets. Among many other benefits, these technologies can provide high fractions of water heating demand at a low capital cost, even in cold or very cool climates. And they can be used standalone or also integrated into virtually any type of heating system, regardless of the primary heating source. Worldwide, the dwellings using solar thermal technologies for water heating reached 250 million in 2020. And to align with the NCE scenario, 290 million new solar units should be installed during this decade. That will mean reaching around 400 million dwellings using solar thermal technologies by 2030. And in relative terms, this will mean at least matching the total deployment of this technology over the previous 2 decades. And in this sense, we know that the contribution from emerging solar thermal technologies will be critical in the coming years. To close, we want to come with some policy recommendations. Of course, there are many more, but we want to highlight here some that we believe are really important in these coming years. Of course, financial instruments that can help to reduce upfront costs and prioritize the deployment of all clean energy technologies and retrofits, especially targeting low income rates. Bans and regulations are also important to support this deployment. For example, the ban of the deployment of fossil fuel technologies in new installations, and promotion of higher energy performance standards. And in this sense, codes and standards, advancing national building codes to promote zero carbon ready metrics and ensure their compliance. The public support to research and development is, of course, really important in order to support innovation and the development of innovative technologies and ramp up their technology learning curves to reduce their costs. Planning instruments in order to develop and enhance national energy planning instruments and integrate them in planning procedures. And to close capacity building, of course, to develop training and upskilling packages to build zero carbon ready buildings and design and install clean energy technologies. And just to close, we recently published 2 very nice reports tracking clean energy progress and the technology and innovation pathways for zero carbon ready buildings by 2030, where we dive a bit more into this topic, and we also provide some other policy recommendations. Of course, in case any of you is interested in that, feel free to follow up. And that was all from our side. So happy to answer any question in the end of the session. And thank you very much for your attention.
Many thanks both to Chiara and Raphael for that global overview of what's happening in decarbonisation in buildings and what we are looking for, what technologies are available to us in particular. We're now going to move on to a China perspective, of course, from Professor Zhang. So Professor Zhang, the floor is yours.
Professor Jiang, you are on mute. You are on mute, Professor Jiang.
Okay. Thanks, May. And my topic is the heat pump. In fact, until now, I'm still in the large conference with 600 participants in Hangzhou. The topic is heat pump conference. We hope the heat pump will play a very important role in the future in China, especially for the space heating task. And the major task for carbon-free energy system of buildings, we believe is 3 tasks. The full electrification of energy in buildings and the carbon-free electricity supplement, try to help the grid system make the electricity really become carbon-free. And the third is carbon-free heat supplement for space heating. This is today's topic. And what is the scale? Here is China energy for building operation. They can be divided into 4 catalogs, and the space heating only in north part of Chinese urban buildings is here is take about 1/4 of the Chinese building operation energy. And here is what changed during the last 10 years. The energy for building, you can see this curve. This for heating, you see, keep to increase due to the increasement of the new building construction from 12 billion square meters need district heating to roughly 16 billion meters last year. And then most of the heat resource until now for district heating is boiler, coal, natural gas boiler, plus CHP plant, exhaust from CHP plant. But for the future, we believe the heat pump may be the solution for space heating, because the function of the heat pump is just draw this heat from low temperature, low grade heat source, and then to raise the level of the heat and release that at a high temperature, higher than the low grade heat source level. but of course you have to input some electricity, we call W. However, in this case, 1 kilogram, 1 energy from the input from the electricity, you can produce COP such as 6, at least 2 type of more heat combined than this input electricity. So we believe that in this way, the heat pump is a very, very high efficiency way to produce heat for space heating. But then the big problem, the challenge is where we can go the low-grade heat. What is the low-grade heat source? Because the heat pump cannot produce heat itself. They can only take the heat from the low-grade heat source, then raise the temperature and release at a high temperature for applications for your heating purpose. And normally we can have the outdoor IR is universal everywhere. We can find outdoor IR without limitation, but they are low efficiency because it's a relative low temperature. You need more power, more electricity to raise the heat. And also the variation during the season for different seasons. So then the performance varies and makes the system, the performance is not very nice. Another problem is the frosting problem. When the outdoor temperature around 0, this also makes a lot of problem. And in addition of this, another big problem is the density, because the heat does come from the air surrounding, so then they can only provide a certain amount of heat for your purpose. For high density heat demand, such as high density buildings, high-rise buildings, you can hardly got so many heat from surrounding air. And then you can make some environmental problem, make the surrounding air temperature go down. So there's a major weakness. So then this can only suitable for low density buildings air, and not for the high density, not for large industry process for heat demand. Then after the air, we think about the surface water like lake, sewage, seawater, and so on. This is quite nice compared with air. The temperature is a little bit higher, but you do have got enough supplement of the water. Is the condition. If we cannot find this kind of source, we cannot use this surface water as a low-grade heat source. And then simple problem as the air heat pump, they cannot support for high density situation. Is for certain amount of water supply. And then we got an underground system, like the water underground circulation, or put a U-tube 1 meter, even more deeply on the ground, so that we can draw some heat from the ground. Then the principle for that, some people make argument. What is the principle? Is to obtain the low-grade heat from the soil, or you just make kind of seasonal heat storage system underground. Means you store the heat during the summer and then get the heat during the winter. It's just the heat storage. What the principle is dependent on the underground water situation. If there are very nice water transfers, then the underground temperature can hardly change without, regardless how many heat you got from that. In this case, you can think it's heat source, is low-grade heat source. However, if there is not enough water transfer, then it's only a heat storage. In this case, you have will to make the balance between the summer and the heat. How much heat you stored during the summer season, you can only take a certain amount of heat from the underground during the winter. You cannot overtake, otherwise the temperature of ground will go down slowly. Another weakness for this underground is also the high density situation, because we have very limited underground soil. For this high-rise building 100 meters high, in this case, it cannot find enough space to support the space heating for this kind of buildings. Then there is other heat sources for heat pump application. That's a big challenge. For low density settlement, okay, no problem. But for high density settlement, such as Chinese large cities in the north, like Beijing, like Tianjin, the heat pump with natural low-grade heat source cannot be the major solution. Then we have to find another kind of low temperature heat resource. What is that? We believe this can be found from the heat exhaust from the industry, like a power plant, oil and steel manufacturer, chemistry and construction materials, and so on. This kind of heat, we believe, is enough for meet the demand of the building space heating. Here is some detailed data for that. How much we need? We need about 5,000 PG for Chinese North urban buildings. Where the 5,000 PG come from? The nuclear power station. In the future, China will build about 200 gigawatt nuclear power on the north part near the sea. And in addition of they produce electricity, annual heat output, they can produce about 3,000 PG. And then also we will keep some thermal power plant for peak load application. And for that, can also produce about 2,000 PG. Then the oil industry like that, at least they can produce 1,500 PG. And then the data center and rubbish burning and all some this service system can also produce some heat, low-grade heat. So in the total, it will be much more than we demand. So as soon as if we can collect 70% from the exhaust, we can meet the demand of the space heating in north part of the China. However, to do that, we have solved 3 problems. First, the unmatched in time, because the heat exhaust from whatever, from power station or from industry, that's for the production of the power of the industry, rather than for the purpose of building heating. So the time they produced and the time they demand is not much each other. For instance, in the summer, in the spring and autumn, the nuclear power station are also operation and produce heat, but the building only need heat during the winter season. So then we do need large-scale seasonal heat storage to store the heat all year and supply the heat when they need. This first challenge. And second, the location problem, because the supply, the location is not always in the same place as where we demand, where the building built. So then we do need long distance heat transportation system at low cost to solve this unmatched in location. And by calculation, we understand roughly the travel distance need about 100 to 150 kilometers distance. If we can make that with reasonable low cost, then we can use this kind of exhaust from industry to meet the heating demand. And the third is the parameters. What the heat come from exhaust, they do have different temperature, different range of the temperature. Such as, for instance, for the chemistry, the temperature is just 30 to 40 degrees C, and for the power plant, the temperature around 30 and so on. So different temperature, if we want to put this together, you have to adjust the temperature go to same level. And then another side, for building, for meet the heating demand, also you need different range of the temperature. So how you make the conversion, make the match between the supply and the demand is another challenge. And for these three, for instance, for the long distance, last 10 years, we did a lot of work, and now we find suitable technology can deliver the heat long distance, like this one in Shanxi province. Also, the natural situation is very complex. High mountain, we have to take a tunnel and also cross rivers many times. But this project has been finished 6 years ago. During the last 6 years, so they running well and make a lot of profit. Because that now, most of the big cities in north part of China now start to build or planning to build the long distance heat transportation system to solve this urban space heating problem in each province city. The second is the heat transformation. Also, we have developed some new technology we call absorb heat exchanger, and to convert the temperature like this one, we can from this 90-25 to convert the heat to this 50-40, or from the low temperature heat source to convert the heat into up to 90 degrees C without put any additional energy. So the ideal system for that application is the large heat supply network. And with this kind of network, we connected with a big heat storage to solve this unmatched in time problem. Then all the staff that can produce some heat, we connected, will supply the heat to the network, and all the heat demanding, whatever buildings or some industry heat demand can get the heat from this network. This kind of heat sharing system based on low-grade heat. And then because the parameters, heat level are all different, then we need a lot of heat pump in the connection, in order to make the parameters of heat uniform. So this kind of thing sounds similar as the 5G DHC in Europe. However, there are still some different. For instance, the low-grade heat source in Europe mainly come from some data center, supermarket, and so on. But China, because we are major industry country, so we have very, very rich industry heat exhaust, and have some thermal power in the future. So then the heat source will something different from Europe. Second, for heat only or for heating and cooling, in Europe, they always say 5G DHC means heating and cooling. We believe for this kind of thing, heating is very high efficiency for use heat pump, but cooling is something differently. We will keep the cooling with normal technology rather than take this network. We do believe that. And the third is the importance of the large-scale heat storage system. We believe this should be the key device in this kind of heat sharing system, because so many heat from industry exhaust, and to well use that, we do need very large-scale heat storage system. And in Europe, it seems not very emphasized for this large-scale heat storage system. So, as a conclusion, we think heat pump will play a very important role in the future in the low carbon or zero carbon society. And the carbon-free heat supplement can be achieved by heat pump plus carbon-free electricity. Then drive the low-grade heat to meet the demand of all the different for building space heatings. And the low-grade heat source is the key for heat pump applications, and for the technology of heat pump selected. Exhaust heat from power station as well as from industry would be the most suitable low-grade heat for heat pump. And heat sharing system of full use of the exhaust heat should be developed for space heating in high-density urban areas. That's my thinking. Thank you. And now we just released a new book, The Decarbonizing Public and Commercial Buildings in China, and everyone will come to take these books. Thank you. Thank you for your attention.
Thank you so much, Professor Jiang. I always find your presentations fascinating. I learn more and more each time I hear you speak. So, and thank you for pulling out those differences between the way China is able to do things and also the way they can be done in Europe. And on that, we'll move to Europe, where actions on energy efficiency improvements are taking centre stage at the moment. There's a huge concern about the heating season that's about to come, and also even more so the heating season after that, because of the levels of gas storage that are available in Europe at the moment. So for this, we're going to pass to Anne Svensson, who's a special consultant at the Danish Energy Agency, and we've had the pleasure to work with on other occasions. So Anne, I'm delighted to welcome you today, and the floor is yours. You appear to be muted, Anne.
No, not hearing from you.
Yeah, I will try. Is it working? Is it working now?
That's better, thank you, yes.
Yes, right.
Okay, can you hear me now?
Yes, thank you, that's clear.
Thank you. I took out the technology then. Yes. Hello, Melanie. It's nice to meet you. It's nice to be here, invited for this event. And thank you also to Tsinghua University So I'm Anna Svensson and I'm working at the Danish Energy Agency, and I'm going to give you an overview of what's going on the European level. So I would like to point out that these are my points and opinions from the Danish Energy Agencies, so I'm not representing the European Union in this. So I will go on and share my screen. And just a short while, I will be ready, I hope. Just bear with me. Yeah. Okay, can you see my screen now?
We can see your screen, Anne. Yes, and it's in presentation mode. So thank you very much.
Great, thank you very much. So just to give you an overview of my presentation here today, I will be talking about the European directives, the Energy Efficiency Directive, and the Energy Performance of Building Directives. And I will also give a little introduction to what's going on in Denmark in order to comply with these directives. So just to give you an overview of where we think we are in Europe, we often claim that we have good technologies and everything, but we also have a lot of challenges. And as Mel just mentioned, right now we have the energy crisis due to shortage of gas supply from Russia. So, but generally speaking, we have a lot of buildings in the European Union countries that are energy inefficient. It's estimated that about 75% of the building stock is energy inefficient, and that more than 35% of the building stock is more than 50 years old. A lot of buildings are even a lot older than that. So the yearly renovation rate is only about 1%. We heard earlier that it would be good from the IEA data that if we could renovate about 20% by 2030, this means a yearly renovation from now on of about 3%, but the fact is that it's only about 1%. And the rate of this renovation for deep renovation, there is a definition for this, but we talk about where we reduce the energy consumption by at least 60%, is only about 0.2% every year. So also we know that about 85 to 95% or most of the buildings will exist still by 2050. So this is not just something here now, this is a long-term perspective we need. And with the current renovation rate, it will take many, many years before the building stock is climate neutral by itself. So we need to look at the existing buildings. So I'm going to go into some of the articles in the European or in the Energy Efficiency Directive. And just for our honorable guests, the way it works in the European Union is that all the countries have a say and all the countries have to agree. And that can sometimes be a little bit of a challenge because there are a lot of differences among the countries. But as what is in the Energy Efficiency Directive for now is a suggestion for renovation of public buildings or a requirement. And here, this Energy Efficiency Directive is also under the revision. So a suggestion is that a target of 1.7% of reduction in public buildings is suggested. But there is at the moment a big discussion, then what is a public building? Is it owned by municipalities or governments, or is it something where municipalities or governments are using the buildings? So the definition of a public building is also being discussed. There is the Article 7, which is suggesting the increase of the renovation of existing building. As I say, it's only about 1% every year that's been renovated. And so the suggestion is 3% of the building stock that must be converted to net zero energy building every year. So again, we have this discussion, what is a net zero building? It was also mentioned by some of the other speakers here, but we need, we're working on a definition on what is a net zero building then. Is it a building with no emissions on ground? Is it a building with no emissions from other places, and so on? So also I would go on to the Article 14, which says promotion of efficiency in heating and cooling. So this Article 14 says that the overall objective is to encourage the identification of cost-effective potential for delivering energy efficiency, principally through the use of cogeneration, efficient district heating and cooling, and the recovery of industrial waste heat. So for efficient heating and cooling, that, as I mentioned, includes the heat from cogeneration and renewable energy sources, recovery of waste heat from industrial processes to meet demand for heating and cooling, and in general, all heating and cooling options that achieve primary energy savings. So I will then move on to the energy performance of buildings directives. And this was established in 2012 and revised again in 2018. And it's now also under revision. So, and this is causing a lot of discussion in the European countries at the moment, because on the one hand, we are, or the European Union is working on much more higher targets for energy savings, but on the other hand, we have all the European countries having other different opinions. So the aim of the new proposal is to reach the target of at least 60% emission reductions by 2030 in the building sector compared to 2015, and to achieve climate neutrality by 2050. So how to do this? One of the suggestions, which is very interesting, is the introduction of minimum energy performance standards for buildings to encourage faster renovation of the worst performing buildings. So we have the labeling system in all the European countries. They work in a little bit of different way, but generally all the countries have the labeling system. So the suggestion is to have the lowest ranking buildings to be renovated. They work from A to F, and the idea is to have all buildings labeled F renovated at a certain point. So, but the countries are then discussing which buildings should that be, and how many buildings should that be, because that puts a high cost on the countries and the building owners, of course. There are also introduced more ambitious visions for buildings to be net zero energy or net zero emission buildings. Again, as I said, there is a discussion of the definition of this. One thing that is going to be introduced, or which has been introduced already, is that each country must provide a national building renovation plan, wherein it is described how each country is going to reach the targets for renovation of existing buildings. So also a lot of this is based on the energy performance certificates. So this is also going to be improved, and more digitalization is going to be introduced into this. Talks are now on whether to introduce also building life cycle analysis, so to include CO2 emissions from building materials, construction, and the operation of the building. And also it has been discussed to increase the requirements for efficiency of heating, ventilation, and cooling. So some of the changes that are proposed are that there will be new demand on digitalization and data exchange. All the countries are working very much on digitalization, and I also see from China that this is a very important subject. The most important part is then that all these digital systems can actually talk to each other and exchange data in one way or another. Again, one of the suggestions is that all new buildings must be zero emission buildings by 2030. And there is also discussions about introducing a renovation passport. So the renovation passport is a description of the building and what we can perhaps use of building materials and so on. Again, what do we mean by deep renovation? Is it a 60% energy saving, or what do we mean by this? So, as I said, these matters are being discussed in the European Parliament. There was even a meeting yesterday. Some of my colleagues attended. So it is an ongoing discussion. It sounds perhaps like they are discussing more in the European Union than they're doing, but usually this all ends up in some kind of revision of this directive. There will be probably some things, some compromises and so on, but we do expect that this is going to be put down within in the near future. So just a word about how do we then do it in Denmark. We are part of the European Union. We have to comply with the rules and regulations. But we also have our own regulations, of course. But we just to give you a brief overview, in Denmark, we have had building codes with energy requirements since 1961. And these requirements have been increased over the years. The requirements in the building code is both for new buildings and for existing buildings, and they are performance-based. So there is a requirement of the annual energy consumption or the annual energy demand. For the time being, it is about 30 kilowatt hours per square meter for a residential building, including heating, hot water, and ventilation. And for commercial buildings, it's about 40 kilowatt hours per square meter, also including lighting and ventilation and air conditioning. Our building code is revised every 5 years, and the next one is due for January 2023. And as you can see on the graph, our requirements have been very strict. So we are at a point where it doesn't really make any sense to increase the level of insulation, the quality of the windows, and so on. So our next step is actually that we're going to introduce life cycle cost analysis or life cycle analysis into our building code as from 1st of January next year. And this means that there must be a documentation of the emissions from the material used for the construction, the transport of the material, the construction of the building, and the operation of the building over a lifetime of 50 years. So we are also, our strategy is to have more district heating in cities, to change oil boilers and gas boilers to heat pumps. It was a very interesting analysis, Mr. Yang, on all the troubles with heat pumps. So there is a lot of challenges if we want to go this way with heat pumps, but that is our strategy. Just to let you know that we mainly have water-based heat pumps, so with water radiators in the buildings. So we also working on all new buildings have to be net zero emissions. We define this by either they are connected to the district heating system, and we have 65% of our buildings are connected already to the district heating system, or they are connected to or supplied with a heat pump. In that way, we define it as a net zero emission building, because our district heating is working with renewable energy sources. Well, our major challenge is, again, the existing buildings and the renovation of these ones, and how to get building owners to do renovations. We use the energy performance certificates very much. We have a digital version, so it's possible to get information and data across the building sector. We are also obliged to look at the public buildings, and have set high targets for the energy renovation of public buildings. And as I say, digitalization is a very important part of our strategy and work. Just again about the heating in Denmark, as I said, this is, you can see here from the left side of the graph from 1980. We had the black line is fossil fuel boilers, so the amount of this has gone down a lot. The amount of district heating, the red line, has gone up quite a lot, and is now, as I say, about 65% of all buildings in Denmark are connected to district heating. In the larger cities, we have about 99% connected to the district heating system. You can see the little yellow line is the heat pumps, and we are expecting to have a very steep increase coming up. We face the same problems as other countries, that there is a shortage of supply in heat pumps. There is a shortage of skilled installers, which is a very important point if you want good heat pumps working. We also need to renovate a lot of the buildings where the heat pumps needs to be installed. So quite a lot of challenges is coming out. But as I say, our strategy on heating is to phase out oil, coal, and natural gas for the production of district heating. We're also increasing the use of large heat pump in district heating. I heard you said, Mr. Yang, that it would be a problem with heat pumps in high-rise buildings. We try to work with systems where we have one centralized large-scale heat pump for a whole building, so that it's not each apartment that needs a heat pump installed. So the electricity for the heat pump is supplied mostly by renewable energy. At the time being, we have 50% wind energy in our electricity system, moving towards 100% renewable in the future. And we are looking at geothermal energy also. We do not have so large resources for geothermal energy in Denmark, but it is also an area we're looking into. So that was my short and brief overview of what's going on in the European level and a little bit about Denmark. So I'm open for questions or comments or remarks, and thank you very much for this event. Thank you.
Thank you so much, Anna. And yeah, you said short, but it was extremely comprehensive. So I think the things I take away particularly, and I think that things that are important to share with our colleagues in China are, the huge renovation challenge that Europe has because of the, say 90% of buildings that will still be around in 2050, that sort of order anyway. But in response to some of the things that Professor Jiang said, that we are in some cases able to look at waste heat from industry, which is of course interesting. But really my big takeaway is the huge progress that Denmark's been able to make, both in decarbonising heating and also reducing energy demand in buildings. So both of those sets of figures are tremendously impressive.
Yeah, if just a short comment there, because our strategy is very much to reduce the energy consumption and then to introduce renewable. Yeah, that's our strategy. If you just change one-to-one from heating to renewable heating, then you still have a lot of challenges. So, yeah.
A lot of challenges and a lot of unnecessary cost, of course. So, yeah. I think it's a great strategy, and you're showing how well you were actually able to implement it. So thank you for that. We're just going to move on to our final presentation of this segment, which comes from Japan. And we're going to have a look at how energy efficiency is evaluated in the Building Energy Code in Japan. And we are delighted to be able to welcome Tako Sawachi from the Building Research Institute, Japan. Mr. Sawachi, we can see your slides. They're on presentation view now. So thank you. The floor is yours.
Okay, thank you very much for your kind introduction. This is the title of my presentation. Mainly, I'm going to talk about evaluation method of energy efficiencies of space heating and air conditioning in the Building Energy Code of Japan. This is the list of the content I'm going to talk about. First of all, this is the reduction target of end-use energy toward 2030 for buildings. You can see the present equivalent oil in billion liter. That is the end-use energy. I mean the end-use energy at present and targeted reduction toward 2030 for end-use energy. On the left-hand side, you can see for commercial and other. This is mainly for commercial building, non-residential buildings. And on the right-hand side, you can see the present situation and the target in 2030 for residential buildings. And this is the trend of Japanese, those two sectors, I mean, commercial building sector and non-residential, residential building sector. I mean, the trend of the end-use energy in Japan. The latest statistics is for 2019. After that, there is no statistics, but I put the target in 2030 so that you can see the how it is going well or not. Okay, so sorry, this is a little bit complicated, but this is just for your information. I can show you the present situation for building energy regulations. Please, if you can get this right afterwards, please look at the yellow highlighted part. That part is for non-residential buildings. By the way, I am focusing only in non-residential buildings, space heating system and HVAC system. I'm not going to talk about those for residential buildings because due to the lack of the time. And this is the incentive programs. Yellow parts are for non-residential building. We have developed, Japanese government developed certification system, which is called BERS. And there have been some subsidy system by the government for ZECHI, zero energy house, and ZEB, zero energy buildings. There is subsidy systems for those kind of buildings. And in this kind of BERS system, I mean certification system and incentive systems, the evaluation tools, I mean energy calculation tool I'm going to talk about is being used for the evaluation. And this is for the future. I mean, in 2030, for non-residential buildings, I mean that before 2025, all non-residential buildings, for them, it will be mandatory for new buildings to comply with the regulations. And government is planning to upgrade standards to zero energy building oriented, which is almost equal to zero carbon ready building standard. I think that Chiara talked about, which is described in Net Zero by 2050, which was published by International Energy Agency in last year. From now on, I'm going to talk about building energy calculation tool for non-residential buildings. You can see yellow highlighted portion of this figure. It is HVAC system, air conditioning system. And starting from that, we are now evaluating the energy performance of the building and equipment system, energy system of the building, starting from HVAC system, hot water supply system, lighting system, ventilation system, which is especially for non-air conditioned systems such as mechanical or electrical rooms, and elevators. All of those components and systems are being evaluated by the energy calculation methodologies. And on the top of this figure, there are some very important parameters to be dealt with in the energy calculation program. First, on the top, you can see room type and floor area of evaluated buildings. This is important because for non-residential buildings, there are many kinds of non-residential buildings, including office building, school building, shop building, hotel building, hospital building, assembly building. So variety of uses are included in non-residential buildings. And we have to deal with all of those kind of variety of non-residential buildings. So it is necessary for us when we evaluate building energy performance of non-residential buildings. The clear definition, clear prescription of the rooms included in the building to be evaluated. I will explain a little bit more detail later. And by using that kind of definition system of room usage, the targeted system will be described. The preparation of input data for the assumption of for the room types in the building should be prepared before starting calculations. And after that, you can see on the right-hand side, pink box. There will be, we will get the reference energy uses per square meters for each room types. By using that, by summing up that, we can have a reference energy uses, total energy uses, reference uses for that building. That reference value shall be compared with the design energy uses, which is the result of the energy calculation. This is only for HVAC system calculation. From above to the bottom. First, on the top, room, space, heating, and cooling laws. They can be called also space, heating, and cooling needs. They shall be calculated in the beginning. After that, the energy consumed for air handling system, or for example, fan coil system, shall be calculated. After that, energy used for pump system shall be calculated. And the last, the energy used for heat generators, heat or cold generators, shall be calculated for HVAC systems. And I'm talking about definition of room usage. Space heating and cooling needs laws are heavily influenced by conditions of room or space usage, such as schedule, internal heat gain, outdoor air intake. And standard condition for 210 room types for 9 building types are prepared for Japanese building energy calculation tools. And after developing this system to prescribe, to define the room usage, we developed international standard, of which number is 18523-1, which has already been published, which includes, which is mainly for the formats of the room usage condition. But as an informative appendix, it includes the Japanese standard condition covering 210 room types and 9 buildings type. And the second very important characteristic of our energy calculation tool is the characteristic of heat and cold generators. Heat and cold generators, including heat pump system, their energy efficiency is estimated taking the partial load ratio at each hour into consideration. We are doing quasi-hourly energy calculation, so the partial load ratio shall be calculated at each hour. And secondly, characteristic of all kinds of heat and cold generator are modeled with these 4 kinds of parameters starting from rated energy efficiency. This only we can get from the catalog or brochure of the made by the manufacturers. After that, we need the partial load ratio characteristic, but it is not easy at present to get that kind of very important information when we evaluate, when we estimate the energy consumption by heat generators. So we are now using default functions as described here. And you can see the figures for the characteristic of heat and cold generators, but I don't have enough time to explain further. From now on, I'm going to introduce some case studies by using this building energy calculation tools. It is about 7-story office building in Tokyo, and total floor area is about 10,000 square meter. And I have done 5 cases starting from case 1 to case 5. The conditions, detailed information is very important, but I have to skip the detail of this table. You can see later what are the characteristics of the cases I'm going to talk about. And this is the result of the cases after finishing the design. I would like to stress that the energy performance of the building, and especially the HVAC system, is heavily influenced by the sizing practices. If the sizing practices is done according to any kind of existing standard for sizing, it will give us very good, relatively good energy performance of building. For case 1, this is for standard practice at present. So the sizing has not been done well enough. So the size of the heat generator, in this case, water chilling units, the size is relatively larger than other cases where good practices for sizing have been done for the design of these 4 cases, starting from case 2 to case 5. And this is the result for case 1 to case 5. Only for HVAC systems, including space heating and space cooling. The vertical axis is calculated primary energy use, megajoule per square meter floor area per year. You can see the great reduction of energy use, less than half compared with the current standard reference value of the energy use for this building. And this is also the result from the calculation. This is the partial load ratio of the buildings. And for case 2 and case 4, You may not know about partial load ratio. Partial load ratio is the ratio between hourly heat needs to be dealt with by the heat and cold generator divided by the capacity. I mean the maximum capacity of the heat and cold generators. And in practice, it is necessary to have a room for the capacity. Otherwise, they will face to the risk of the lack of the capacity of the heat generator. So it is natural to see this result. You can see partial load ratio mostly below 0.5, I mean less than 50%. This graph shows that the evaluation of the actual energy efficiency of heat pump system and other heat and cold generators, their energy efficiency under low partial load ratio, such as below 50%. It is very important task now we are facing when we try to design better performance, especially for space heating and cooling building. This is very important. And this is a result for overall energy usage. You can see that after case 2, we have a ratio against reference energy use, black line, you can see the right-hand side vertical axis. This shows by design carefully, it is very feasible to get the result, the ratio against reference energy use below 0.5. 0.5 is a very good performance at present. And this is the last slide of my presentation, still existing issues for us. For the first, the following energy saving technologies have not yet been evaluated mainly due to the lack of design standards specifications. You know very well about VWV, VAV, and CO2 control of outdoor intake, very popular for practitioners. But when we try to evaluate accurately their effectiveness in saving energy, we have to define very accurately, strictly, what kind of design the practitioners are going to make. So I am saying that there is a lack of design standard and specification when we try to evaluate those very important energy saving technologies in the regulations. The second, characteristic function for heat and cold generators with improved energy efficiency, especially under low partial load ratio conditions. As I said in my presentation, we are now using default functions for characteristic function, but there are already in the market, there are some very good, for example, heat pump system with much better characteristics than the default functions. So now we are trying to develop the testing standard for those very good heat and cold generators. At the last, I'd like to say that the better harmonization between standards in the two kinds of world. One world is of heating cooling equipment and heating cooling equipment, and another world is buildings with equipment integrated in themselves. So, for example, in Europe, there are two kinds of directives: eco design directive, and on the other side, for buildings, there is EPBD, Energy Performance Building Directives. Ideally, they should be harmonized. The same thing is happening in Japan. Not only in Japan, maybe North America, it's happening. So I would like to stress that better harmonization between those two worlds, I think it is very important in the future. Thank you very much.
And thank you very much for that really comprehensive presentation and for ending on that very important note. And it's kind of why we're here having these conversations. The concept of harmonization both between countries and of course continents, but also between our own regulations. It's an important point to make that we have our building regulations clearly and our appliance ones, and they need to work seamlessly together. We need them both to be performing optimally, of course, to reach our net zero ambitions. So we've taken a quick gallop across the world. We've started with an overview globally. We've looked at the situation in China specifically. We've had a look at what's going on in Europe, and we now heard from Japan. I think that's a great way of opening this meeting, this 8th meeting between IEA and Tsinghua. And I'm very pleased now to hand over to my colleague Araceli to take on the next panel. Araceli, over to you.
Thank you very much, everyone. I hope you can hear me well.
Yes.
Perfect. Thanks as well. And we're just moving to a new session now. Also in the interest of time, we're gonna have as well 4 very distinguished speakers as well with us to share some of the views on the recent trends when it comes to the currently available solutions for heat decarbonization, but also discussing the opportunities for clean technologies in terms of advancing deployment, and also how we can make the most or exploit better some of the available sources when it comes to waste heat, for instance, and certainly the importance as well of coordinating energy policies with different building-related policies to ensure the affordability of this type of solutions, and then we can reduce costs of these applications as quickly as possible. So I won't hold you for longer and just wanted to introduce the first speaker, which is Professor Zhang Shudong. He's the Vice Dean of the Architecture School at Tsinghua University, and he's going to present on technology advancements for fossil-free distributed heating applications. Professor Zhang is a specialist in sustainable technologies for China's rural housing, indoor air pollutant sources, and control technologies. So we're really eager to get his views on this topic. So please, the floor is yours, Professor Zhang, and you're welcome to this discussion.
Thank you, Araceli. Just give me a minute to share the screen. Yes, here. Okay, I hope you can see my screen now.
Yeah, it's all perfect.
Okay, thank you, everybody. So my topic is actually about heating in the individual houses. It's a little bit different than what Professor Jiang just talked about a while ago, and also focus on the fossil-free heating technologies, what are already available and what might be used in the future. So this is the outline. First is a little bit background information, and then I will mainly talk about 2 technologies. One is the breakthrough in the air source heat pump, and the other one is the innovation in the solar PV heating with storage. And then a quick summary and conclusion. I think this is mainly for China, but I think also applies to many other developing countries. Solid fuels are still widely used for household heating in rural areas, mainly due to the reason of the low cost and also the familiarity of the farmers. Some people use coal, some people use the solid wood or the raw biomass. And of course, you know, this can cause a lot of problems indoor air pollution, outdoor air pollution, and also increase the health burden. So certainly we want to get rid of these very inefficient and also very polluting source for heating. So we are talking about a few options for non-centralized clean heating. So this is actually, as I mentioned, this is not just a Chinese issue. This is a worldwide issue. You can find a number of solutions. For example, you can use natural gas heating. However, it actually will increase a lot of costs compared to the coal heating. And also in many parts of China, so availability is a main issue. And also there's no infrastructure in the rural area to pipe the natural gas. And of course, also safety issue, and natural gas is a fossil fuel, so it can generate CO2 emissions. So it's really not very encouraged to be used in China, although it's much cleaner compared to coal burning. The second technology is certainly also being considered is a processed biomass, plus the clean heating stoves. I know this has been widely used in Europe and also start to be considered in China. But also there is a limitation. For example, if you use this in a small house, then you need to consider where to get the biomass pellets and how to process these biomass pellets. And also there is a concern of the pollution control and monitoring, because this is a small stove, so you cannot really put a lot of sensors to measure the pollutant emissions. Solar thermal heating, people put a lot of hope. And of course, there is quick development also in some places. However, it's also limited due to the high initial cost, and also solar itself cannot work completely independently, and you need an auxiliary heating source. And also you need to consider anti-freezing. So these also limit the application of the solar thermal heating in the individual households. So then we have another options, like the low ambient temperature air source heat pump, and also another one, the solar PV heating with the thermal storage. So these are what I'm going to focus on today. The air source heat pump, as Professor Jiang just mentioned, you can use this to transfer heat from the source of the outdoor air, which is available everywhere, and then you deliver the heat into the house. And this is usually measured by the so-called coefficient of performance. So when you have a COP larger than 1, that means for every 1 kilowatt hour of electricity used, you generate much higher proportion of the heat into the house. So this is much more energy efficient compared to the direct heating device. And of course, due to the nature of the thermodynamic cycle and the heat transfer process, the heat pump is not very favorable when the indoor to outdoor temperature is very large. In other words, when your indoor temperature is fixed and when the outdoor temperature becomes lower, then the heat pump doesn't really like to work well. So that's a major issue we have to overcome. So conventional heat pump in the cold area face a lot of challenges. Number one, the heating capacity is insufficient in the cold ambient conditions. When the outdoor temperature gets lower, you need much more heating demand, but the heat pump is actually going to provide less heat. So this is the main contradictory issue. And also, because of this, there's relatively low reliability in cold ambient conditions. So due to the lack of the compression ratio match, and also a lot of other technical reasons, I'm not going to go to very detailed. And also there's another challenge, that is, if you want to use air type air source, for example, you use warm air to heat the house, then there is also a problem of low thermal comfort when you heat the house. So this is not like a water-based heat pump system using the radiator. So then how to solve this problem? So there is a technology innovation to use from the change from the traditional single state compressor with one cylinder into the double stage enthalpy added compressor, either with 2 cylinders and also or with 3 cylinders. So with this technology enhancement, you can enhance the capacity in cold climate condition because you can increase the refrigerant circulation rate when auto temperatures get lower. And the COP is up to 2.0 or plus when auto temperature is as low as -20°C, and it can still run normally when the auto temperature is below 35°C. So this actually is very desirable when you use a heat pump in the cold climate. So this figure shows how we compare this traditional heat pump with the renovated heat pump system. So when the auto temperature gets lower than -20, the traditional heat pump doesn't work well. And also the COP is much lower compared to what I just talked about, the double compression type of heat pump. Regarding how to improve the thermal comfort, there are different types of improvement or different ways of improving. So what I'm showing here is the first generation. So when you use this heat pump for cooling, this looks like a traditional split type air conditioner. So you blow air horizontally and the cold air drops down. So you generate certain kind of thermal comfort. But when you use this for heating, then the air must blow downward rather than horizontally. Otherwise, you cannot generate relatively comfortable environment for the lower zone, which is the people's occupied zone. So this certainly needs improvement. But I think the most significant improvement is like this. So rather than put this hang on in the higher level, we can put the terminal unit at the lower level. So then you have 2 different kinds of air blowers. So on the lower level, very low level, it can generate like a very comfortable floor heating effect. And then this air can quickly heat up the air. So you can increase the indoor air temperature within 10 minutes. So that can make sure when you are not using the equipment, you can turn it off. When you come back, you just turn it on and the temperature goes up very, very quickly. So this is the first type of generation 2, and this is another type of generation 2 terminal unit. So this both way can provide a very comfortable thermal comfort effect for people. And also another very important thing is that a heat pump must be able to work with occupant control behavior. For example, if you have an individual temperature requirement, some people want 15 degrees C, some people want 20 degrees C, then you should be able to do that through your control remote controller. And also when the room is not occupied, you should be able to turn it off. And then when you come back, you should be able to turn it on and the temperature should be able to increase very quickly. So that can add a lot of potential for energy saving. So this is very, very important point when you use a heat pump. So that means you have a lot of requirements for this. For example, easily adjustable indoor temperature. So you must be able to provide individual comfort control. And also we know rooms are not all occupied at all times. So it should be able to allow partial space, partial time control, easy to operate and maintain. So it must be user friendly. Even the children or elder people can easily operate that. And also it should be able to wield high on the energy ladder. So good feeling in social status. This is also a very tricky issue in a lot of rural families. And also very important thing is that it should be able to be affordable in both the initial and operating cost. So that's a key for market penetration. So a lot of requirements if the technology can be used. So just want to show you some of the work we have done about the operation, how this kind of unit can work with occupant control behavior. So we actually select the number of houses and then we monitor the occupant control of each of the units in different rooms. So we found that in some of the rooms, people use it almost continuously. So you see, it's almost 23 hours a day. But in many other places, you can only probably run 9 hours a day, or even it could be very irregular, like only 2 hours a day in average. So then that can lead to very large difference in terms of energy consumption. So in this case, It's only 11 kilowatt-hour per square meter per winter. So it's very energy efficient. And not because the building envelope is highly efficient, but because of the occupant behavior. You work with that, and then you can save a lot of energy. So with that, I think this technology is relatively mature and is actually already being widely used in China. So the example I show here is in Beijing. Many of you know Beijing went through an energy transition in rural area. So from coal to clean energy, and the major technology that the rural household use is air source heat pump. Some use water-based, some use warm air-based. But this goes to very, very complete transition. So more than 1 million small coal boilers were removed within a couple of years. And actually they reduced more than 3 million tons of scattered coal. No, it's not 300 million. 3 million tons of scattered coal was reduced. So it reached a very high, very large environmental benefit. So this is what it looks like before, and this is what it looks like now. So much, much better clean air. And people worry whether this unit can really work in the extremely cold climate. So we chose 2 different locations. One is very north of China in Heilongjiang province. So they have extremely cold climate condition in winter. So you can see that the unit works very well in the whole winter, and the energy consumption is not high. It's only 22 kilowatt-hour per day for a 65 square meter house. So if you convert this into per square meter, it's still very acceptable. Another example we tested is even further north, is in the Gers of Mongolia. So you see this is the Gers, and they put the outdoor unit and the indoor unit there. And when the temperature goes negative 30 degrees C, so the indoor temperature can be as comfortable as 18 degrees C to 28 degrees C, depends on how they want the temperature to be. So that means this unit can really work with a very harsh climate, like even in Mongolia. So in summary, the unit is very simple to install. You have outdoor unit, you have an indoor unit, so it's a lower cost. So initial cost is only about 4,500 yuan per unit. So you can convert this to US dollar, is about $500 for the initial cost per unit. And the COP is more than 3 in Beijing climate. And operating costs, because it can work with occupant control behavior and also has a relatively high COP, so the operating cost is also very acceptable. It's 15 to 40 kilowatt-hour per square meter per winter time. I maybe just quickly go over another technology I want to share with you, and that is the solar PV heating. We all are very familiar with the solar thermal heating system, but compared to the solar thermal heating, the PV heating actually has a lot of several advantages. First of all, the PV heating has a higher year-round usage. So in the heating season, you provide heating, but in the non-heating season, it can still generate electricity. So you can sell to the grid or self-consumed. And also the PV heating system is simple in structure and occupies less space. So people like to use this kind of so-called lightweight heating system. How does the system work? Well, this shows the schematic of the technology. So this is a PV, and then this is a converter, and then you have the electrical wire to release the heat from the PV. And very importantly, you must have the thermal energy storage so that you can heat the house in the nighttime or when there's no solar, the room is still warm. So there's a thermal energy storage wall, and also there is an insulation layer so that you can prevent the heat from being released to the outside. In other words, model heat should be stay inside rather than leaking to the outside. So there's no battery for energy storage. So that makes the system very cost effective. And also we want to make sure that the indoor temperature is stable and reliable at night or on holiday days, as I just mentioned. So this shows how the system looks like. The system looks simple, but the mechanism or it requires very complex model calculation and optimization. So before we start this test, we actually simulate the building thermal load and combine with the PV power prediction model. So we optimize the capacity and also the storage capacity of the system. So we can show that, you can see that, of course, it's not a stable temperature because the outdoor temperature is, outdoor solar is varying, but it can maintain relatively comfortable range for indoor temperature. So we then, with that, we selected 5 different households in the rural community. So these are the pictures of the households. So we actually tested different ways. The first 2 households, we use the so-called optimized parameters between the ratio of the PV panel to the heating area and also between the ratio of the heat storage wall area to the heating area. And the other 3 demonstration houses, we try to reduce or use a different parameter and see how they run. So as a result, the first 2 houses, it's not surprising, it provides relatively comfortable temperature. So and most of the time it's above 15 degrees C. 15 degrees C is considered as a comfortable temperature for the rural households. And for the other 3, because they use less ideal or less optimized parameters, so there is certain decrease of the temperature. And also we also try to understand at the nighttime how the temperature changes. So it's a very small temperature drop at nighttime, even though there's no heating, direct heating into the wall. Because of storage, it can maintain relatively stable temperature. And the worst scenario is that when you have a cloudy day, there's no solar heating for the whole 24 hours or even for 2 days. The temperature drop is still not very quick. So that means it gives you very much stabilized thermal environment compared to some system without a thermal storage. So I just want to quickly summarize about what I just talked about. The first of all, the innovative 3-type low ambient temperature air source heat pump has been developed and commercialized for the individual heating in all weather winter conditions around the globe. So that means it does not necessarily work with Chinese climate. It could all work in Europe, or in America, in Africa, in all different climate conditions. And secondly, a novel solar PV heating with thermal storage has been proposed and tested for whole winter, which can provide desired indoor heating in winter and electricity in other seasons. So this can be used all year around. It's not just used for winter. In other seasons, you still provide electricity and you can sell it to the grid. And so the results indicate both technologies, first of all, can avoid the use of the fossil fuels such as coal and natural gas. They can meet various individual thermal comfort needs, have significant energy saving potential, and also be cheaper. This is very important. Be cheaper in operating costs compared to the fossil burning stalls. So people just ask why it can be cheaper compared to the coal burning system. So because the efficiency is much higher, and also because of other ways of improve the technology. So, but I think there are a lot of further studies need to be conducted. For example, how this system perform in the most sophisticated conditions, and also how to make sure that the PV system work with the power grid. I think that's a challenge. So we are currently working with these issues and try to develop more different kind of scenarios and to share with you maybe next year. Thank you.
Thank you very much for this comprehensive presentation. Those are very interesting points. I think the importance of considering specific the application and the context in which the technology is going to be applied is very crucial. And of course, seeing as well all the opportunities on how innovation can help make most of these kind of tailored applications as well. And certainly having into account all these practical considerations as well when it comes to the operational control of the technology. I think that's very important points. Those were very important points made there. Let me now go through the second speaker that we have for this session, which is Richard Lowes. He's a senior associate of the Regulatory Assistance Project. This is an ongoing policy environment which in Europe is driving the decarbonization of heat in buildings. Dr. Richard Laws is a specialist in the technology and policy associated with heating within Europe program at RAP as well. So very pleased to have you with us today, Richard, and please, the floor is yours.
Thank you very much, and good morning. It's a pleasure to be here. Thanks for asking me to speak. So I've got some slides. Sorry, my camera appears to be flickering a bit at my end. Not much I can do about that now. Does it look okay to you?
It is fine. It's very subtle, so I think that's okay.
Okay, great. Okay, let me just share my screen. I hope that looks okay. Great. Okay. Well, I've got a few minutes now to talk about policies for heat decarbonisation. And when I tend to think about policies for heat, I normally think about specific technologies or places. And so I was asked to put this in a sort of European, but also global context. So this is really my best attempt to try and pull lots of different streams of thinking together. It will be an overview, so don't expect lots of detail. But I'll focus at the end on, I guess, the next steps and some of the key themes that we think about. So I'll start off by talking about the very big level things in terms of governance and approaches to economics, then focus a bit more on more local planning. And then at the end, I'll move towards talking about heat pump deployment policy specifically. So the first thing I wanted to say is that the existing structure of particular countries or regions or areas is very important when we think about heat decarbonisation. I think historically energy policy has taken much more of a market-based approach, and that's because we have been focusing on grid scale technologies and big schemes. Whereas when we think about heat decarbonisation, we need to think more locally, and I'll get back to the reasons for that afterwards. But a few of the things we need to consider when it comes to governance and market structure are that central planning will be very important for the transition towards clean heating. In many situations, it's central planning that's got us towards where we are with existing heat systems, so the development of power grids or gas grids or coal infrastructure and distribution. And it's less popular, it's less fashionable now to do such central planning in certain states, although that's not the case everywhere, and that varies around the world. But for some of the things that we need to do, there will be an element of central planning needed. And so we need to be aware of that in the context of the fact that certain countries are less good at central planning and certain countries are much better at central planning. So that's the first point on market structure. The second point is that there's generally expected to be a much bigger role for policy making and governance around energy for heat at a local level. And so when we look at Europe, there are very different examples of countries, but we're increasingly seeing places like the Netherlands, which has a much more municipal based around cities and small regions, that structure becoming more important. And so in general, we're seeing a move of policymaking from the centre, from centres of powers and national governments towards more local settings. And that ties up quite neatly, I think, with the fact that more central planning is needed in some ways, because the central planning can create the environment for local governance, and then the local governance and planning at a local level can sort of fit within that framework. And finally, we also need to be aware that certain states, certain nations and areas have much more economically liberal approaches. So the political economy really matters. And there's a huge spectrum in terms of countries' approaches to economics, from very, very liberal markets, such as the UK or the US, to more tightly controlled markets, perhaps Germany here, in a European perspective, and China from a national and global perspective. But for those more economically liberal markets, it's apparent that tools based around pricing and regulation are likely to be more important than those based for central planning. And there's an English proverb that's a very straightforward one that I wanted to introduce here, which is quite simply horses for courses. And it's so straightforward, it shouldn't need much explanation. But basically, what this saying means is that certain horses are suited very well to particular race courses. And when we think about heat decarbonisation policy, we need to be aware of that, the fact that certain heat policies will be suitable only for certain nations and for certain areas. So that's my first overarching point around market and governance. The second point is around geography. So historically, many policymakers, or certainly in recent years, I should say, have not thought too much about the geography of energy systems. And national policies have been introduced, and these have been applied often through a market framework. But when we look at this technology mix, the change in heating mix, and this is from the IEA's central net zero scenario, we can see that as well as a huge number of heat pumps deployed, so the graph on the right-hand side here shows the number of heating appliances installed across now by 2020, I mean, 2030 and 2050. And so we can see a huge growth in the number of heat pumps in general is expected. But also a very significant growth in the number of heat networks. So the role of district heating also increasing, which has obviously been discussed already this morning. And the development of district heating local solutions naturally means that policymakers need to think in a much more geographically specific way, taking into account things like population density, heat demand, and so on, in planning their strategies for heat decarbonisation. But also designing policies for how they fit in with those strategies for heat decarbonisation. And I just thought it was worth highlighting now an example of some heat planning work and some more geographically focused work that's taken place in Europe across the past decade, which is called Heat Roadmap Europe. And what the project did was it basically mapped the heat demands of certain European countries, and we've got a map here that includes Germany on the left, the Netherlands to the north, and excuse me, by mapping the populations and the heat demand, it then allows you to understand where you put solutions like heat networks, because these need the government intervention, the central planning. And once you've got those maps and those plans, you can then develop a strategy to deliver heat decarbonisation. And you can also understand where other technologies, building focused technologies such as heat pumps and solar thermal will go. So overall geography increasingly important amidst the local planning and the need for local governance reform. And the big piece from the technology sort of transformation and policy perspective is around heat pumps. And this is an extract of a paper that myself and some colleagues wrote, which is in Nature Energy, called Heating Up the Global Heat Pump Market. So you can search for that and it's open access. And we compared current, and as part of the paper, I should say, we compared current heat pump deployment, which is the solid line on the bottom, the blue line, and then it becomes the orange line, to the number of heat pumps suggested in the IEA's net zero pathway from the graph I've just shown you. And what you can see is that immediately the number of heat pumps needs to grow quite significantly. And beyond 2025, that rate gets extremely fast. And there is a big gap there. And we're talking about, more than doubling the current number of heat pumps by 2030, and going obviously much further than that by 2050. And there is a huge gap there that policy needs to fill. I'm just going to spend the final few minutes of my presentation talking about the elements that can fill those gaps. So this is a graphic which has been extracted from a not yet published report called the Heat Pump Policy Toolkit, which RAP, along with our partners CLASP, who are experts in appliance standards, and GBPN, who are experts in building fabric efficiency standards. We're publishing this during COP in mid-November. And specifically, this is a toolkit about how you promote heat pump deployment around the world. So we're taking a global outlook and we're looking at all of the options available to promote heat pumps. And there are a few big things to take into account here. So we've used the structure of a Greek temple, and in the report we go into much more detail. But basically, the roof of the temple represents the heat pump market, a sustainable and strong heat pump market, which is aligned with our global net zero goals. And to support that market, 3 pillars are needed on top of a solid foundational base. And I'll just talk through those pillars briefly. But the key takeaway, I think, from this and from the report, which is upcoming, is that to reach mass heat pump deployment levels, just picking one of these pillars or one of these elements won't be enough. And so policymakers need to design packages of policies which include all of the pillars and potentially multiple elements from each of the pillars in order to drive heat pump markets at the rate needed. And those packages of policies need to also include a really thorough look at the governance structure and all of the various policy elements and softer policy elements, including things like skills, communication, and engagement to build a package. And so pillar 1 is about the economics of clean heating. And so basically what this pillar suggests is that for general consumers and for citizens and for building owners, policymakers need to ensure that the market pricing and price signals overall reflect the fact that clean heating is clean, reflects the fact that it's low carbon. And so when we think about energy prices and energy bills, policymakers need to ensure that those bills for people switching to heat pumps incentivize heat pumps, so that when you have a heat pump, it's cheaper to run than a fossil fueled heating system. And so shifting the market towards clean heating solutions and shifting prices towards clean heating solutions is one important pillar. However, that won't be enough alone. Pricing and signals from a policy context have significant value, I think, for industry, but actually building owners and people do not respond quite so well to pricing because of things like access to capital, because of culture, and because of social expectations. And so while pricing might be an important element, and it surely is, more on top is needed. And so the second pillar of the policy toolkit for heat pumps is about financial support. So the financial support element is that allowing households and building owners to actually switch towards clean heating, because more often than not, and it's not always the case, and there are different examples of this, and the example of the air-to-air heat pump in the previous presentation is a good example of this. But often if you're switching from fossil fueled heating to low carbon heating to a heat pump, for example, it will cost more. The first time switch will cost more than simply replacing your existing fossil fuel system with another fossil fuel system. And so governments need to ensure that there is support there for households. That could be subsidies and grants. It could be the availability of loans, and it could be the provision of finance and packages through other means. But basically, people need to be able to afford to switch to clean heating in that first upfront switch. And that's the second policy pillar of our heat pump package. And then finally, there's an important role here for regulation. Regulation can do many things. In the case of heat pumps, it could be that buildings are regulated. So when building works are done through building codes, although building codes aren't everywhere, certainly not in full detail, but building codes could include requirements for clean heating. Equally, appliance standards, requirements for producing appliances, which currently include things like pollutants, air pollutants, or carbon emissions, they could also be transformed to incentivize clean heating. And the package of those 3 pillars, the economic change, the financial support, and the regulation, if you have those 3 things on a foundation of communication, coordination, skill building, together, we think that those packages are what can be created to most rapidly, but also most sustainably create massive heat pump deployment, which is really what we need to get to meet our zero carbon goals around heating. So I appreciate that's a quick overview of the policy toolkit. That's upcoming from RAP and our partners and will be available within about a couple of weeks now. So just to wrap up, a few final points. Firstly, I just want to emphasize this point that heat decarbonisation requires multiple policy reforms. Not just one element will do. It needs to include things like governance reform, the actual process of making policy, because we're changing geography and we're changing the scale at which we're looking to do things. And it will require changes to local planning. Subsidies are very likely to be required, and that might just be grants, economic and pricing reform, and regulation. All of those things need to be considered together. Secondly, it's worth pointing out that we're actually still quite early in terms of learning what works for heat decarbonisation. We've based a lot of our research and our thought leadership around existing organisations and existing countries who've done lots of progress here. Scandinavia being a key example where, Nordic countries, I should say more specifically, where heat pump deployment has been very rapid and very significant. But those countries were transitioning away from oil. And actually, we don't have a good example of a country which has successfully transitioned away from gas heating. And so we're spending a lot of our time considering the countries that are trying to transition away from gas heating, how successful they're being. The one thing I haven't mentioned also is that heat decarbonisation, the actual decarbonisation of heating systems, also needs to be considered alongside developments and progress in increasing the fabric energy efficiency of buildings. And when you're creating your heat policies, that needs to be wrapped up potentially in packages which also include things like efficiency, airtightness, better glazing and doors, because that can make heat decarbonisation much cheaper, and it can make it much easier, although it does make the policy process more complex. And just finally, I want to point out that there are fora globally, including the Clean Heat Forum, which RAP and some of our partners are involved with, which works via UNEP, which is looking to promote and share policy best practices for heating. And we are hoping that there'll be some exciting announcements around buildings at COP this year. But do feel free to get in contact with RAP or myself if you'd like to join any of these fora or have any further questions. Thank you very much for your time.
Thank you very much, Richard, for this comprehensive overview. I think it's very interesting to see these different approaches and strategies around different regions in the world, and the importance of having a strategy in place that is tailored to specific regional considerations as well. And this idea certainly that we have to learn from each other, so how we can boost also international collaboration that on that aspect to make sure that, again, we can accelerate transition by sharing learnings on that front. Thanks a lot for this. Let me then move to the third presenter, which is Professor Xia Zhenzhen from the Architecture School of Tsinghua University. He's going to present on possible opportunities to integrate waste heat in district heating systems. Professor Xia has been researching in different topics, mainly on online building energy monitoring systems and building energy diagnostics for HVAC system innovation and district energy. So very pleased as well to have you with us today, Professor Xia, and the floor is yours, please. I believe you are muted, Professor. We can.
Okay.
Yeah, now it's good. Thanks.
Yes, again, sorry for that. I forget mute. So again, thank you, Arisley. It's really my great pleasure to be here today to share some information about what we did for the past 10 years on the industry with the heat applications. So I'd like to have a very quick review for the background. I think that's already mentioned by the experts before for today's forum. So you can see here, and perfectly. Okay, so we have a huge growth demand for the heating in the northern part of China. You can see over here, is that every year we have increasing for the floor area, and which is going to be reaching for around 20 billion square meters in 2050. On the other hand, you can see that if looking on the heating resources right now, we still heavily rely on this coal and the gas-fired boilers, which contribute to around 40%. So that's the reason why we think about low carbon resources, which are heavily needed for the building heating sectors. On the other hand, in China, we're still the heavy industry countries. So 70% of our total energy are consumed by the industry, and which need to a huge amount of the waste heat which are released. So even looking in the future, a lot of people talk about industry structural reform. We believe that they're still going to have a certain amount of the heavy industry remains, and which are producing the products which for our future development. So that's also the reason, if you look on the currently quite a lot of policies at state level or even some local government levels, and even for some industry sectors which are released for this, some action plans which need to that how we could promote the utilization of this low-grade waste heat from the industry to some other purpose like the building sectors and so on. And when we go a little bit deeper, even deeper for these industry sectors, you will just find out that not just the heavy industry previously we just mentioned, like steel, cement, chemical, which are producing a lot of waste heats, which have rich for industry waste heat resources. And also we have some other non-processed industries like food sectors and also paper industry, pharmacy, and so on, and plastic. And so you will find out they also lead a lot of medium or low level heat. And currently they're using like the coal-fired boilers or gas-fired boilers, or even some high-pressure steams coming from the power plants. So we believe that in the future, definitely this part of the heat demand also should be considered on how we could find a proper way to decarbonization. Maybe it's not directly related to the building sector, but if you look on the city level, definitely this part need to be considered. So that's the reason that we believe that we need to answer some questions about how, if before we trying to do this industry waste heat application, this question could be that how much we have recently, and what could be happening in the future, how much we have for this industry waste heat resources, and where it's located, and what kind of heat we have according to temperature and different types of the material, the influence that could be have. So that's why actually a couple of years ago we started to conduct this part of research. We're trying to look on the data resources which can provide in what we have right now for the industry processing, which coming from the bottom up, from the top down. We go through the statistics yearbook and look on the geography data. And meanwhile, we also have the bottom-up research for the specific locations and also some field investigations, and trying to covering for all the resources we could have recently and within the industry sectors. And meanwhile, we think the forecast of the future, how much industry waste heats we still remaining, could be quite important. So we take these influence factors like energy structure reform, industry restructure, and also even for the population change and urban developments, which are could relate for all this industry in the field, how they could change to that. And based on that, I can see that we are covering almost more than 90% risk for the current situation about what's the industry which it have, and which could providing quite accurate results in the future when we apply this industry with heat application. And also we think about in the future, because right now, if you look on the industry itself, it's also talking about decarbonization. So quite a lot of low carbon energy could be applied in the future, like the hydrogen, electricity, and the biomass material, and so on. So all these parts we believe that could be considered when we in the future, when we think about what we could have for the industry waste heat potential. So within all this part of methodology and data supports, and we got some quite interesting results, which need to that what we have. For example, over here, we did quite detailed surveys on more than 200, like nearly 300 steel factories in China, and not only in the northern part, also in the southern part, because we believe that it's also could be good heat resources which are for this non-processing industry, and which means that you can see that we have a heat potential like more than 130,000 million watts and around 3.7 billion gigajoule of the heat. And then we also working together with China Iron and Steel Associations talk about in the future, what could we have? So the conclusion draws that it could be half of the products comparing with the current situation. We believe that could be happening for the steel factory in the 2050, which means that we have around 500 to 700 million tons of steel could be produced. And within that part, half of them could be the electric valence steel making, not like currently we're using the coke or some other coal long processing steel producing. So within that part still, we can see that we have much less, but still like some 1.4 billion gigajoule of the heat could be used in the future in the steel factory. The same we did for the coke, and so due to time limit, I'm not going to go through for all of them. And also for the cements, you can see the distribution are more bright comparing with the steel and some other factories, and also for the copper and for the chemicals. So comparing with some other heavy industry, for another chemical are a little bit different within the current situation and within the future. What's going to happen? They keep increasing, and like previously talking about steel and the cements, they're decreasing like the half of the producing to 2050, but chemicals actually they keep increasing. So which need to that we have more potentials in the future. We have this kind of the heat could be used. So quick summary for what we have for the current situation and what's going to be happening in 2050 for the industry waste heat resources. We'll find out that actually we have half left, nearly half left, comparing with current stations. So this needs to be really very carefully considered for the currently when you're trying to apply for this kind of applications. You need to really consider if this factory is still remaining there and what's going to happen for the next 20 years. And then we will find out that most of these heat were located like in the certain province, like the Hebei province. We know that they produce a lot of steel, Shanxi province and the Shandong province and Liaoning province. So good information that most of them are in the northern part of China. So it could be quite a good match with what we're talking about using this waste heat for our buildings heating in the winter. And also, I think we not only the heavy industry, which is mentioned before, and we believe that the heat coming from the power plants would be quite important. So there's already quite a lot of discussions about in the future what could happen for our electricity sectors, and we believe that it could be a lot of renewable energy which go into the electric sectors. But however, we think in the future, thermal power plants still could play the quite important roles, which are mainly using for the regulation, for the peak loads regulations, and trying to meet for the leads, especially in the winter time when we don't have enough solar or the wind and the water and so on. So this is hypothesis. Actually, we're working together with some electric experts, and which are providing that in the 2050 we're still going to remaining around 800 million kilowatts of the summer power plants, comparing with current situation is around 1,200 million, so around nearly half of the capacity, but running with much less hours, mainly focus on the winter time for the peak load regulating. Another part is that we believe the nuclear power plants along the seaside in China also could play quite important roles, because its power plants are running yearly around so much longer operation hours. So we need to have much more waste heat could be could be applicated in the future. So I think some experts also mentioned for data centers, so that's why we also take apart calculations on that. And according to this data providing, we'll find out that actually it also could be quite big, huge amounts of the heat from the data center. Data center here, I just mentioned, actually it's for large stations of data center, which go for around 1 billion of the gigajoule. And also for the urban usage and the garbage waste. And we believe that it also could be a very good resources in the future for our low carbon heating resources. So we also did some very quickly calculations on that. So previously just mentioned on the supply side what we have, and also we need to answer the questions of what we need. So the first part is that we did some urban heat forecasting, especially for the northern part of China, and based on the residential population forecast and the urbanization rates and the building area, and also talking about energy efficiency of the building sectors, and because they're going to reduce for heat demands in the future. And here are more detailed results. So I will not go too deep inside because of the time. And also for energy efficient retrofitting patterns. For example, we have 3 patterns like slow, medium, fast, and which need to the different demands for what we really need for the northern part of China. So here comes the results. If we take into account the all this route mapping for the northern cities, which are around 1,047, and with the population, each of them with a population more than half million. So totally, if we also including in the Yangtze River, and what people think we do need heating for that regions because of the climate situations. So totally together, we have roughly around 5 million of the gigajoule of the heat which are needed, according to this median rates of the retrofitting rates. If you go too faster, maybe this part of the demand could be even reduced a little bit. So, but we take these numbers just for our planning in the future. And also we did for this long processing industry, and over at least here you can see the distribution are mainly along the east parts of China, and we can see that they even have more heating demands comparing what's happening for the northern part of China, 6.9 billion of gigajoule. It's also, we need to think about the domestic hot water. And so we did some roughly calculations, which go to around 1.1 to 1.6 billion of the gigajoule in the future, according to the population and talking water we really needed. So totally, we add everything together, and here is the heat demand what we needed, and here is what we have within the waste heat resources. And we can find that it's quite good to match with each other, which means that even with the switch the heat, we already can cover them for all the needed in the future. But of course, we need to consider them for the technology and for the resources, and they're not going to be 100% fully recovered. So we need to go a little bit deeper, trying to see that how we could match these two together. So the first part that's we looking on the locations. So you can see we have the 3 map over here looking on the demand, and this is for the supply side. Unfortunately, they're not matching properly. So that's why we believe that's it, because the heat is not like the electricity, they can go very long distance distributions. So we need to have a certain area so that we could match which is just supply side and demand side. And that's the reason why previously, like Professor Li Jiang mentioned, that we need to have this long distance distribution within the heat could transport from within the 200 kilometers, and that could be matching much better comparing with current situation. The second part is that if you're looking on the current situation and the future, if you look on the current situation, you can find that we will have more than enough heat which could cover in for all the heat which are needed. But in the future, due to this industry restructure and also due to this thermal power plants reducing the capacity, we'll find out that actually we don't have enough in the winter time, but we have more than enough in the summertime, because most of the industry will find out they're running the whole year, also including for the nuclear power plants. So that's the reason why we believe that a seasonal storage for the industry application with the heat application becomes extremely important. so that we could match within our supply side and demand side. So unlikely what happened in Europe, you start with a lot of the solar heat, but here we believe that the industry with the heat storage could be more efficient and much cheaper in the future. Another situation to mention that we're looking on the quality of the waste heat resources. Over here, we just put all the waste heat quality together. You'll find out 40% of this waste heat are low grade, which are within temperature lower than 50%. But we're looking on what's really needed for the non-processing industry. Most of them, they need the temperature higher than 50 or even go to 100. For our buildings, maybe we need around 20 or 30 would be good enough. But if we want to distribute this waste heat with long distance, we still need to have larger temperature difference. We need to increase this waste heat temperature, trying to distribute it to the proper area which are really needed. So that's why we need some heat pump to help us to increase the quality of the waste heat in order to match for the demand side. So a quick summarizing for this part. I think industry heat has huge potentials, can be very efficiently used to reducing the carbon emission in the future for the building sectors and also for the industry sector itself. And right now, I think we already have quite a lot of application cases, and some of our IEA colleagues already paid visit to some of these application cases, like the waste recovery of the Tianxi steel plant and the Chifeng power plant and so on. Recently, we can see that more than 100 of the projects are running and in China, in northern part of China, which are using the waste heat from the steel factories. But still, we believe that there's some problems or some challenges in the future if we want to fully utilization of our industrial waste heat, for example, seasonal storage. Okay, so and due to this unbalance between the summertime and the winter time, we need this seasonal storage to help us in a very large scale seasonal storage and heat pump. And previously we had some discussion. People think about that. So the waste heat could compete with the heat pump, but actually we believe that it's not just compete; it should work together. And the waste heat, it actually is like some kind of the heat resource which could couple together with heat pump, like air source, ground source. But here, if you use a waste heat source, heat pumps, and it has huge potentials in the future. We use in this kind of the heat pumps, electric drive or absorption drive, heat drive absorption machine. Heat pump could be used over here. And meanwhile, long distance piping network, and they could solve us for the problems of geographic locations mismatch. And that's also right now, we believe that it could be quite good, important infrastructures could be installed in the future. Okay, I think that's all for my presentations. Thank you, and I'm just waiting for any questions. Thank you.
Thanks a lot, Professor Xie. I think this is very comprehensive overview. I think it's very interesting to see the results of all of these detailed mapping studies. I think that's crucial when it comes to understand this potential for waste heat, and in particular, the very important aspect as you flagged on, how is this going to evolve in the future? So it's not only understanding today, but how these different activities producing this waste heat are going to be transformed in the future. So that's really, really important, the foundation for this work. Thanks a lot for this. Let me just pass to our last speaker in this session, which is Shen Jiangong. He's a researcher at the Chinese National Institute of Standardization. He will now present the role of standards and how they can play such an important task to support the affordable and efficient growth of the heat pump market. This is an area which has been an important driver of growth in high efficiency appliances in China. So we're very eager to learn more about that experience and to share those learnings with us. So thanks again for joining us, and please, the floor is yours.
Thank you very much to the moderator. Hello, everybody. But first of all, let me share my screen. I'm sorry. I'm sorry. Let me adjust the format just a little bit. My apologies. I don't know how I can do it, but Mr. Cheng is trying to get some technical support from his colleague to see how it seems that he would like to record. He would like to record the slides presentation, but it seems that he does not know how to do it. It seems that he has added some background sound into the slides, and he wonders how he can do that. He wants to remove the background sound. He's trying to remove the animation and switch to the manual mode. My apologies. In fact, in China, energy efficiency standards has been a very important consideration for energy efficiency in buildings. And I think after years of implementation, we have achieved desirable results because it seems that the standards worked very effectively and contributed significantly to the achievement of the targets of carbon emission reduction. In fact, the standards have been around in refrigerator sector for many years, and I think, in fact, it has become a very well-built framework by which we're able to phase out inefficient product. But on the other hand, when a product is efficient, when its performance is high, then we have devised instruments to incentivize the procurement and the use of such product. And I think over the years, the system has played a very important role in China and has been very well received by the general public.
At present, the Chinese government has introduced national policies and incentives. Here I'm showing you some of them. For example, the outline of national standardization development and measures for the administration of the mandatory national standards. Now, the gist of these policies is first to significantly improve the level of standardization, and secondly, to align China's standards with international practices and standards. That way we could drive energy efficiency performance in China so that we could cope with the climate change and other challenges. Besides, these policies are not just about conserving energy, they're also about refrigerant replacement. Now, these are two priorities in the cooling sector, and I must say both are very important to energy conservation and emission reduction, and also China's targets for carbon peaking and carbon neutrality. So these policies create the framework for our actions. Since the 14th five-year plan was launched and since the outline of the national standardization development was set in motion, a lot of follow-ups have been done. So far, we've looked into the main products available in the market, including the AC air conditioner and also heating devices. We categorized them into 20 to 30 categories. They are used in different sectors and scenarios. We have the energy efficiency standards mostly for the home appliance and also the cooling systems for households and industrial purposes. The emerging sectors such as transport and communication do not have that many energy efficiency standards. So this is one area where we need to do more, and we will do more in the future. Besides, in order to improve the energy efficiency of the products in the market, we have been doing the following things. First, we will further improve, as I said, the energy efficiency of the products. Secondly, we will facilitate the electrification nationwide. So when we talk about the heat pump and also the cooling, a big trend here is electrification. And the third path is the integration of new energy sources. The air conditioner and also the heat pumps could use new energies, for example, solar, green electricity, and also PV. All of them need to fit together. And the fourth pathway is to improve the system itself. Currently, much of what has been done is about single or individual devices or equipment. Going forward, we would improve the design and also the system design and management of the entire system for energy conservation. Right here is a list of some measures being implemented in China, including in the 14th five-year plan. And most recently, the government agencies have come up with a number of targets to meet the carbon peaking and carbon neutrality targets. There is an important milestone, 2030, and these targets come in different types. First, the energy efficiency for the cooling products, and also the energy and also the transition to clean heating pumps and also clean energy sources. The share of these, there have been targets for the share of these products. And for example, the market share of green products by 2022 will be 20%, and the additions of buildings will be fully electrified. So these are examples, some examples of the targets we have, targets that are being achieved as part of the 14th five-year plan. To meet these targets, we believe in the power of standard setting and standard revision. First, we are revising the standards for energy efficiency. The first is for the IEC room air conditioner, which is probably the most common home appliance in China. About 100 billion units have been produced in China. That's about 70 or 80% of the global total. So naturally, this is where also the most efforts have been made. Some of the efforts are to introduce new standards for new products. For example, we've introduced consistent standards for the fixed frequency and variable frequency IACs. In 2018, I think these two types of technologies split have a market share split of 40 to 60%. And it was decided that variable frequency technology will be gradually phased in. So in the chart to the right, you will see an increase in the share of the variable frequency technology. It's now the dominant technology. In 2022, 98% of IACs use variable frequency technology. So the transition has basically been done. And some other measures are about new products. For example, one such product is low ambient temperature air source heat pump for IAC. This is also, we have also introduced standards for this particular heat pump. It has effectively generated benefits when measured by the energy efficiency of this product and also the market share. But this is just one of the new products that we have brought into our standard system. So we have seen a 30% improvement in the energy efficiency of IECs because of what we have done. The second main product is the multi-split air conditioner, which has a big market share in China. So what we have done is to improve the energy efficiency of the multi-split AC by as much as about 40%. So a lot of low efficient products have been phased out. They have been outcompeted. And secondly, we've looked into the features of the multi-split AC, and so based on what we have found, we introduced new low temperature testing points. These low ambient temperature split heat pumps have a big market share in the cold areas, but we previously did not have energy efficiency standards for this. So in some way, we filled this gap. That way, we have been able to improve the energy efficiency of low ambient temperature multi-split heat pump. Besides, in this market, the low ambient temperature multi-split heat pumps are increasingly popular. They are apt for northern China, where the temperature is usually low, and we've set standards for these heat pumps. The purpose is to make sure that the market players can also have standards to follow, and that their products can also be more energy efficient. Now, the third category of products is the water chiller. Now, the water chiller units have long been an existing technology. We've also had standards for them, mainly for the water chiller units. But because the other products are also there, so we've introduced the standards for example, these water chillers for buildings, and also the absorption chillers, the water ground source heat pump water chillers, and also some other new products. we've also set standards for the high discharge temperature water chillers. Now, these chillers are usually used for generating hot water supply for households and also for industrial users. Their market shares are all going up, so that's why we have introduced new standards for them. Again, the purpose is to help them succeed in the market, in particular the highly efficient products. We want them to have a bigger share in the market. But currently, these standards are still under revision. Hopefully, when these standards are finalized, we will be in a better position to do better job in energy efficiency. I also want to say a few words about the electrification of buildings, a very hot topic. In particular, in China, the Ministry of, China's Housing and Urban Rural Development Authority has set certain standards and policies. As you can see, there are many two pathways towards the electrification of buildings. The first is a switch to the heat pumps for space heating, or the replacement of the coal heating system. The natural gas or coal will not be used that much in the future. In their place will be the heat pumps due to the energy concerns. So we have already set the standards for the low ambient temperature heat pumps, mainly to be adopted in northern China and also in areas where the transition from coal to electricity heating is underway. And I must say this transition has already generated a lot of results. Another technology is the medium low temperature heat pump units. So much has been talked about how to use the exhausted heat from power generation, power plants or other industrial sources for heating. So far we haven't set a standard for this particular scenario. And going forward, we plan to introduce energy efficiency standards for the potential heating sources for the space heating. Another area is the household hot water supply, heat pumps, water heater, and also the gas, and also the natural gas hot water boiler, and also the electric water heaters with water storage are the main technologies here. And the natural gas and hot water boiler accounts for about 60% of the market here. We want to cover all of these products in our standards. That way, going forward, we would replace the natural gas and water boilers with the electric water heaters or the heat pump water heaters. That's going to be very challenging, but certainly worthwhile because of the benefits on energy efficiency and the climate change management. The government is actively working to drive this transition. As I said, we plan to transition towards heat pump water heaters supplemented by the electric water heaters in order to drive decarbonization of this market. So that's about standardization.
Hopefully in the future, we will come up with more detailed standards in support of this transition. Thank you very much. That concludes my presentation.
Thank you very much for that overview. I think it's very important, the points made, and my takeaway was, this important to transit as well from the focus in specific equipment to the holistic system level perspective, and to make sure that all these standards are compatible and talk to each other and consistent. So thanks really a lot for this. I think we are running a bit out of time, so we are going to skip the questions that we had, so the time for questions that we had planned in the agenda, so we can move directly to the roundtable and then address all the points that have been raised through the Q&A box, and I'm sure that the audience will have as well. So let me hand it over to Professor Xie so he can moderate this roundtable as well. Thanks everyone, to all the speakers.
Okay, thank you, Arisley. Yes, we're a little bit behind the schedule, but I think it's worth of the time since our experts really present rich, full information on the presentations. So I think we go for section 3, this roundtable discussions on finding the near-term solutions for decarbonization of heat in buildings. So actually, we designed three. Sorry, I think we have some. Okay, we designed 3 topics during this roundtable discussions, which are focused on the policy by the government and also the financial solutions and also the technical solutions as well. So before we started this roundtable discussions, I would like to have the briefly introduction for our distinguished guests, which are going to participate for this discussion. The first one will be the Ms. Ye Ang from the Team Leader Division of Urban Energy Transition, a German energy agency, and Mr. Sun Xiaoliang from the Executive Deputy Director and the Secretary General of ESCO Community of China Energy Conservation Association, AMCA. And we have Pauline Lucas, Miss Pauline Lucas from the Policy Director, European Power. And we have Mr. Wang Zhigao, Senior Program Director, Low Carbon Cities Program, Energy Foundation China. And Mr. Miha Babik, Vice President for Buildings from Danfoss. And Ms. Tina He from Senior Association, the Carbon Trust. And Mr. Zhao Hengyi, Executive Vice General Secretary at China Heat Pump Alliance and CHPA. And we have Mr. Wang Chongfei, Senior Engineers, China Association of Refrigeration. And Mr. Zhang Longai, Assistant General Manager of Commercial AC R&D Departments, Green. So 9 distinguished guests which are going to participate for this roundtable discussion. And so the topic 1 will be the actions taken by governments in building heating sectors in preparing for the upcoming winter. So the first question I would like to go for Ms. Ye Ang. As Ms. Yang, you have already involving in a lot of projects which are exploring the solutions for the green city or low carbon cities in Germany and in China. So what kind of actions do you think the government can be taken in order to support the increasing undertaking for these heating solutions, low carbon heating solutions?
Thank you, Professor Xia, for your introduction. I'm very happy to be here today. And before I go to the details, I think I can introduce myself a little bit more detailed, because I'm not only for DINA, for the German energy agencies here. Indeed, I was also invited by IEA Energy Efficiency Hub, because European Commission and Germany are leading a new task group for energy efficient in buildings. So I think it's just for a background. And for your questions, I think regards to the upcoming winter, we indeed have this energy crisis, as Anna from DEA said in the former sessions. And for the German government or from the municipal side, we see the call for the demand side. That means the German government is giving rules for the municipal buildings that they have limits of indoor temperatures. I think it's about 17 degrees. And it's also call for saving energy on the private households. So now we see the Germany is very dependent on gas at this stage, and the gas situation is kind of solved. We have 95% fuel. in our gas tanks, and the winter is quite warm till now. So I think to think of this question in a whole setting, we need to be aware that if we can improve the building energy efficiency, especially for envelope, and account to which with the climate change in the future, so it is very important to give a very thoughtful forecast for development. So we are still observing the situation. I think we all notice that the situation is unstable, but in all these situations, we have also good examples. We have in Germany, municipalities, they have already worked on that. They have their own delivers from biogas from the surrounding areas. And we have also regions, they have green hydrogens in their own systems. So all these municipalities, they are now the showcase for other municipalities to take on their work also and to learn from them. So we as DINA has set up a competence center for municipality heating planning and heating development center to do the capacity building for municipalities, how to set up a more sustainable heating system. And this is our work, not only refer to the upcoming winter, but I think in the next 3 to 5 years, we will have more of these cases with biogas, with regional solutions. Thank you.
Okay, thank you for Mr. Yang about introduction about what we did in German. I believe that you're using to talk about biogas and hydrogen applications in the future, which for these low carbon solutions. And what about heat pump? Just a little bit quick about for today's topic. Yeah.
It's a very good question. So my colleagues are working very, it's a big difficulty actually in Germany now because all these production has bottlenecks and they have problem with chips, maybe from China. So the production is having problems. So we want to give a heat pump more increasement in short term, but it's we are lack of products. We are also lack of skilled workers who can install that. So one of our solutions is kind of do kind of retrofit works in prefabricated way, so we can shorten at least the building construction time, but still we need to get back to the capacity building issue that all these works should be trained properly. So we in Germany is indeed facing this problem, and we think or we hope it will be solved sooner or later.
Okay, thank you very much for Ms. Yang, your interesting introduction about the German case. Okay, so we go for our second guest. A second question will go for Mr. Sun Xiaoliang, and I will ask you in Chinese. Okay, 这个孙秘书长，我问题是这样。
Hi, Mr. Sun, here is my question. In fact, your association has provided a lot of help to businesses in this sector. And I wonder, I would be interested to hear some more on the roles of ASCO can play in accelerating uptake of low carbon technologies. Hi, Professor Xia, dear experts. It is a great pleasure for me to be here at this workshop. We at ANGA are an industrial organization, and internationally we are known as ASCO. And I do believe ASCO is a feasible solution in support of a retrofitting project towards a lower carbon development. Just now, the role of government has been mentioned. So what I would like to talk a little about government policies. In fact, when it comes to energy efficiency in buildings, an important role is for the public institutions to play. and they are part of the public buildings, but their bills are shouldered by the government. And a number showed that as of 2020, there's 1.58 million such organizations, which consume 160 million tons of standard coals. If we are able to improve their energy efficiency, not only will we be able to cut their energy consumption, but we'll also set very good examples across the rest of the country, because I believe heating and cooling account for over 60% of energy consumption by buildings. But luckily this year, the Ministry of Finance and the NDRC, along with other competent authorities, have released a new document that encourages the public institutions to use a contract trustee partnership for their management in the by an arrangement by which professional energy management companies will come in and they will take over the management of energy consumption by those public institutions. And I think that is a very good model, and the document is released by the central government, and soon after that, local level governments have also followed up with the release of their local governments for implementation. For instance, the authority in Hebei province released a document which is essentially a notice for implementation of this document, in which it is said that before the end of this year, each city will need to implement at least one retrofitting project to save energy and cut carbon emission. In particular, it says that if an organization's energy consumption is over 500 or even 2,000 tons of standard coal, they will need to have completed the retrofitting project to cut energy consumption and carbon emission by the end of the next year. And all the organizations of a similar nature will also need to complete such a retrofitting project by the end of the 14th five-year plan period. And also previously, there was also a government that offers tax incentive, in particular the tax incentive in terms of exemption of income tax in the first 3 years, and then just 50% of income tax in the several years that followed based on their energy performance. And we are very happy to be able to participate in the revision of this document in collaboration with the NDRC, the Ministry of Finance, and the and other competent authorities. Essentially, this is to encourage the retrofitting of existing buildings or public institutions so that they can improve their performance in terms of water consumption and energy consumption. And I do believe those efforts will significantly contribute to the effort to cut carbon emission and energy consumption across the country in China.
Thank you for the answer. I do believe that MTA has done a lot in facilitating the project implementation and also in informing government decision making. So much has been done. In particular, from what you have said, it's clear that the public buildings have been a starting point, one area where best practices might be generated so as to drive industry-wide decarbonization. And I think this approach can work very well.
So our third question, I would like to go for Ms. Lucas. I think you're already here. Okay, so the questions that I think just 1 week ago, I think 10 EU organizations, including Euroheat and Power, they just urge the European countries trying to implement a 10-point plan, which for successful heating and cooling transitions. So could you have some brief introduction about what is this 10-point plans, and also what will be the government rules in this 10-point plans? Thank you.
Thank you, Professor. So happy to represent district heating and cooling industry today. We are focusing on advocacy towards the EU institution, just to replace us a little bit in the context, and we encourage sustainable heating and cooling, and also, of course, the development of district heating and cooling to achieve climate and energy targets. So what we saw in the EU context was a very high margin for improvement to better address heating and cooling in the EU debate. So that was the basis for this 10-point plan. The challenge is really sizable, as some colleagues of us reminded us. The EU consumes half of its energy for heating and cooling purposes, and mainly for space and water heating. And the main consumer of this thermal energy are households and commercial and public buildings. And over 30% of those needs are covered by natural gas, and only 23% by renewables. So this is a little bit what we aim at tackling with this plan. There are currently two major EU energy initiatives ongoing. One called the Fit for 55 package. So this one aims at reducing greenhouse gases emission by 55% compared to 1990 by 2030, and achieving net zero emission by 2050. And therefore, it tackles renewables, energy efficiency, and building renovations. So that's the first one that existed before the energy crisis started in spring. And in response to the energy crisis, the EU has released the Repower EU, which is another package that really aims at coping with the energy crisis, ensuring resilience by energy saving, the diversification of supply, and also, of course, substitution of fossil fuels. So here we've seen a really hard push for heat pumps, with 30 million newly installed heat pumps in 2030. And also, of course, the push for development and modernization of district heating, so together with large-scale heat pump, geothermal, and solar thermal. But we believe, as IEA Power, as well as other stakeholders, actually more than 10 that are also co-signatories of this plan, that we can do a lot more to push this existing technology, such as heat pumps or district heating, further. So as Professor, you were saying, we launched last week this 10-point plan that is really an industry-wide initiative signed by many other EU associations, as well as a city network and an NGO. And we are still growing the number of signatories of the initiative to continue disseminate the plan. So the basic request that the industry is doing to the EU institution and the EU Commission is to develop a robust EU heating and cooling strategy to really align the climate with our climate law, and also the ongoing energy security imperatives. So this is our basic ask, because this heating and cooling strategy dates back from 2016, and there is an urgent need to update it. Then if we go more into details, we are calling to develop a holistic approach to building renovation. So not only building by building, but really connecting building with local, renewable and sustainable waste heat and renewable heat sources. Also, as the colleague reminded us, there is a very strong importance of heat or energy planning. So we're also calling the EU institution to introduce mandatory heat planning for local authorities. This is a prerequisite to the development of district heating and cooling. We also obviously need a financing framework and a robust one to de-risk investment in sustainable district heating. We know that these investments are specific and have low long-term return on investment. So we need the adequate framework for that. And last but not least, we would also like to call for a ban on individual fossil-only boilers in new, refurbished, and deeply renovated buildings. So these are a few of our key asks from this 10-point plan. I think it will be available after the workshop. You can find it on our website, europeanpower.org. And yeah, if you know other trade associations or organizations that are interested in joining this effort to really call the EU policymaker to go further and accelerate the heat transition, please come to us and we can discuss and act together. Thank you.
Okay, thank you for Pauline for your really interesting introducing about what we did here right now in the European Union, and also for this 10-point plans. We believe that actually it's really quite interesting if you're looking on more detailed for this 10-point plans. We believe that's, for example, you mentioned about this high-level strategy design, energy planning, and also a lot of different type of technical solutions. Actually, I think we could learn not just for European Union, even for some other countries also could learn quite a lot from these actions. Thank you very much for that. Thank you. Thank you. Okay, so that will be, I think, because we're a little bit behind schedule, so I'm going to leave all the questions for at the end.
I was on the phone trying to get hold of them because it was going through. You can't do this because you haven't accepted.
Okay, so mail. Okay, we go for the topic 2. Okay, so after this, just the policy part, we go to the financial part on how we could find the financial solutions for retrofitting and for accelerated deployments for the best available heating technologies. So our first question will go for Mr. Wang Zhigao. So I think Mr. Wang Zhigao, are you there or not?
Yes, Professor Xia, I'm here.
Okay, okay, that's great.
You hear me
so,
okay?
Yes, very good, very good. The sound is very good. So the questions that essentially are coming from the Energy Foundation and the Carbon City programs, I think we would like to know that how does your programs running to looking for promoting these financial solutions for the low carbon city? And could you give us some good examples for that, please?
Okay, thank you, Professor Xia, and thank you, the meeting organizers, and as one of the supporting organization for this event, I congratulate to the organizing committee, and it's a great pleasure to be here. I've already learned a lot. Talking about clean heating finance, there are indeed a lot of challenges. So many experts have reiterated some of the challenges, like high upfront cost, potentially maybe for some technologies, higher cost for maintenance due to a lack of more complication and a lack of expertise, and a new technology, lack of scale of economy, etc. And also behavior and habits, user behavior and habits, user inertia. So that's, and also including the externalities for fossil fuels, not internalized. So all this add up actually makes the overall, cost or scale up of new technologies very challenging, very difficult. So that said, sustainable financial models are critical. So I actually are quite new to this field, but I would like to share a few personal thoughts on improving the financial models. First of all, I think we need to improve the use of public funds and public resources. There are a lot of government funding for example, to support the clean heating pilot programs, national rural grid upgrading programs, gas heating subsidies in some cities, and heating retrofit subsidies for government buildings, as Mr. Sun just mentioned. I think coordinate and direct or divert all this government fundings towards proven, mature clean heating technologies are very important. I think we need to consider that in future policy design, especially the coordination among different funding sources and different purposes. Second one is I think we can even do something on the planning side. For example, the heat pumps. Many believe that for the Chinese high-rise buildings, the heat pumps installation is very challenging given its dimension and volumes. So the space limit, how do we solve that? One of that is during the planning stage. We can work with the developers to give them FAR reward, for example, a floor area ratio reward, so they can get higher development capacity to make them to do a better design to accommodate heat pumps. Also, there are other things, public resources we can use, for example, land price discount or tax waiver for developers. So just to give them additional money or additional capital to install all those new heating technologies. Second one is improve the financial models by private sectors. There are a lot of solutions. I wouldn't go into details. For example, financing lease and green loan products, green finance products. There are many, including green insurance services to guarantee the performance of these new heating solutions. A third aspect is capitalize or capture the social, economic, and eco values of new heating solutions. One example is, for example, the carbon mitigation for big clean heating retrofit project. For example, some of the professors in Tsinghua did the long distance heat transmission program. And according to their estimation, there's a huge potential for carbon mitigation. But how do we capitalize that or capture the value of those benefits and convert that into a stable cash flow? For example, through carbon trading or other mechanism that will help reduce future operating cost. Talking about our organization, the role of Energy Foundation China, we are a public, basically a philanthropic organization. We collect funding from international private foundations and fund research and technical support for mostly in domestic China. So we do three types of things. In terms of clean heating, I think I'm just thinking about how we can contribute to that. I think we can support research and analysis to define a fuller cost-benefit picture of the new heating technologies. And identify market distortion. I believe there are a lot of market distortion. That's one reason that some new technology cannot be scaled up quickly, so that we can inform decision makers to improve policy design and regulation, such as improve building design standards to accommodate new heating technologies like heat pumps. And to design help the financing organizations or private sectors to better develop the financing mechanism, and to develop policies to better regulate market access for different products, or improve product quality control, etc. We do all this through policy study and policy research. So second is, I think there are a lot of lessons and good experiences and best practices in this field. We need to summarize or synergize all these things to communicate those to decision makers and the general public, to give them a fuller picture, cost-benefit picture, for example, to improve their awareness of the true benefit of new solutions and help them to make the right decision. Lastly, we also traditionally we also support pilots for new solutions, not in terms of investing capital cost, but in terms of giving planning and technical support. For example, develop a conceptual plan, etc. I look forward to work with experts in the field to jointly promote heating solutions in China. Thank you.
Thank you for Mr. Wang Zhigao. You just share our, we shared with us rich full experience on this financial solutions for this low carbon heating technology. And yes, I think we learned also quite a lot from your experience about how we could, fully utilization for the different sources like public foundations, private foundations, and also we believe that this policy design, the business models in the future definitely is so important, so that we could accelerate for development for our best available heating technologies and so on. And we can see that Energy Foundation also involving a lot of case studies like the real projects supports. So that's also could helps a lot in the future. So if we could design the more detailed, the supports within the policy part, financial part as well. Thank you very much for Mr. Wang Zhigao. Definitely we feel that we should cooperate together in the future within the field. Okay.
Thank you.
So thank you again. So our second question goes for Mr. Sun Xiaoliang again in Chinese.
Hi, Mr. Sun. Just now, you offered us your insights on policies, the role of ANCA in support of this low carbon transition. In particular, when it comes to commercial and a business model, I am sure ESCOs are confronted with a lot of challenges. So could you share with us some of the potential solutions? Take, for instance, just now, Mr. Wang Zhigao also talked about it, because sometimes compared to conventional technologies, the cost is higher. At least the upfront cost for new technology is likely to be higher. What kind of potential financial solutions are there? You tell us a little bit about it. Okay, thank you very much. As I've explained to you, we are responsible for the implementation of ESCOs. When we do a project, we got the technology, we got the financial resources to provide the services for the clients, and we also work on maintenance and operation. And our area of expertise is in the field of heating, in particular for through a low carbon source. So for heating project, this is also a very nice way of raising fund, because we provide the source of financing. And in order to promote the implementation of this model that is known as ESCO, we also developed a national standard, because in the past we also only have one model, but now we have 3 different models in the national standards that was first implemented in 2022, and with a standard format of a contract in that standard as well. So hopefully in the future, this is going to play a role. And also ESCO need to raise financing. And a little bit earlier, CBRC introduced 2 documents. The first is the guideline for a green credit, by which the CBRC instructed the financial institutions in China to provide more support for us for green financing. The percentage currently is set at 6% for financial institutions. And also CBRC introduced a guideline for energy efficiency, which prioritizes the financing towards energy efficiency project. That includes both the organizations that consume energy and companies like ESCOs, who provide services and a source of financing in support of the implementation of energy project. And I think the last time I checked last year, the Central Bank of China also introduced supportive tools for carbon reduction, emission reduction. There are also measures from the State Council in that department as well. And just in my previous intervention, I talked about public organizations, public institutions. And today I've got some good news because I've received a guest from a bank who told us if ESCO works on public institutions on such project, now I'm allowed to, as long as you win the bid in competitive bidding, we are allowed to provide financial support to you. I think that is a very good piece of news for us, because that way we can definitely that'll definitely help us address a lot of financial difficulties. I think the difficulty right now is not about the cost of financing, but first and most importantly, the difficulty resides with the access to source of financing. Not to say that the cost of financing is not important at all. So in any case, the project we are working on, we've got PV solar plus pump. And in this project, the model we achieved is that the contract sharing model with the duration of 10 years, and also the sewage source heat pump. There's one such a project that is intended to provide a heating, cooling through to the industrial park through what we describe as the trusteeship program. And there are also other projects that seek to retrofit the existing infrastructure with the duration of the contract of over 20 years. There are also projects whereby different technologies are adopted, especially through the model of what we describe as the contract management model. In fact, I think those are all areas where we as ESCOs can contribute to. Okay, thank you very much, Mr. Sun, for sharing with us those very interesting case studies. The different technological pathways and the role of a green financing, and in the role that the financial institutions are now allowed to play in support of the implementation of those projects. Those are indeed a very interesting case studies. And I think in the future, definitely more efforts need to be made in that direction so that we can benefit more technologies. Thank you once again, Mr. Sun.
Okay, so for this section, the third question will go for Mr. Barik from Danfoss. Mr. Boris, are you there?
Yes, I am.
Yes, Mr. Barik. Okay, nice to see you. And so I think Danfoss is a very successful manufacturer in China. And the question goes for you will be that what type of the financial support you think or financial solutions that could help the manufacturers which are supporting for this faster undertaking for these high efficiency heat pumps or some other, there's technologies which are in the building sectors. So.
Yeah, thank you very much for the question. Thank you for invitation to such a prestigious conference, and good afternoon from my side. Let me introduce first Danfoss. Danfoss is an international company who has a large footprint in China as well. We are actually into all of the products which we do are in energy efficiency solutions. That means Either we do mobile hydronics, or we do motor control, or we do climate solutions, which is heating and cooling or refrigeration part. Me myself, I've been responsible for buildings in this as a business unit. So if let me start at the beginning, explaining the financial solutions, because then it will the whole story will make sense. So if you look at the energy uses across, so we actually see that 50% of the energy is used in buildings. So that's a relatively high share, and that for sure is something which we would need to consider as a first target for saving, right? But then on the other hand, on the long run, the sector coupling, so coupling between electricity, transport, and buildings would actually make the optimal mix of energy blend and usage between the storage, production, and distribution. So that means the buildings are actually playing essential part. And then if you go further, if you look at the building as such, a building would be actually made out of three parts. One part would be, of course, the envelopes, how the building looks like, the insulation on the building, the windows, and so on. Then a second part would be the generation part. So whether this is connection to district heating, or is it a heat pump, or even traditional boiler. And then we have a third part, which is actually connecting both. It's the distribution. So it's the energy distribution part. And if we then deep dive further into energy distribution part, we can actually look in the hydronic system that we can do nothing to distribute the water, or we actually do kind of a manual solution, or we do a dynamic solution. So if you do nothing, that means that the energy which we will produce with the energy source will be just freely distributed, and means that the users which are physically closer to the source will actually get more energy than the ones further away. That will significantly increase the pumping cost and decrease the efficiency of the source. And then further, if we do the manual balancing, that would actually mean that we balance it in the maximum operating conditions, which are typically 10, maximum 15% of the year. And then if you go to the dynamic solution, that would actually mean that we will have in each and every operating point optimal distribution of the water. And then going further to the apartments, to the rooms, then of course, if we take radiator, of course we can do nothing, or we do manual valves, or we do self-acting thermostatic valve, or we do electronic valves. That would mean, again, low energy efficiency at the maximum conditions, energy efficiency at every condition, and energy efficiency which actually gives feedback to the source and actually optimize the source. So that means that there are very different solutions in the spectrum of energy efficiency and how the energy is used. And therefore, strongly believe that financing solutions should actually focus on this. So if the regulators could actually first help the users to recognize which are the most energy efficient solutions, and then secondly, do some financial incentives, or even better, free of charge consulting on the energy efficiency of the building, then that would actually bring the most value for the money. Because if you look investment versus the benefits of fixing the energy distribution versus the envelope of the building versus the new source, that's actually the lowest hanging fruit. It's kind of also answering the previous question. What we can do to the upcoming winter is actually fix the energy flows. And then all the financing solutions should actually focus first on fixing or retrofitting the energy distribution, and then going further to the envelope, going further to the source, because at the end of the day, we need to come to the rounded solution to the energy efficiency throughout all, and not just buildings, but throughout all the energy sectors. And then to make this thing sustainable, not just for this winter, then one idea is actually that performance contracting. So the companies who actually do the energy contracting could have some tax incentives to work even more, to actually expand, to get more jobs done. And then last but not least, when the things are done, normally what happens to heating systems, they just are there in the basement and in the walls of the buildings, and nobody touch them. So it's essential that also there are incentives for the maintenance of the system afterwards, because these systems are very complex systems which need the proper maintenance. And nevertheless, the technology actually goes right now with the very big steps, and the retrofitting to the newest solution always would actually benefit also going us forward. Yeah, thank you.
Thank you for Mr. Bavik. Gave a very, very interesting insights about when we think about our energy systems or the heating systems in the future. I fully agree with that. But partly we need to find some kind of like the dynamic solutions, you know, not just static one, and think about the long term or something, even the lifetime, you know, the analysis to see that which could be the proper way they can implicate it in the future for the energy systems, and not just focus on a limitation on the building sectors, but build a bigger picture for this, like the energy sectors and the influence factors as well, so on. Yeah, I think it's quite interesting insights for these topics. Again, of course, different financial solutions or could be support with this kind of the insight as well. Thank you very much for Mr. Bavik.
Yeah, thank you.
And thank you. So our last question for topic 2 will go for Ms. Tina He, and from the Carbon Trust. So Ms. He, I think we can notice that you have already involved in a lot of projects which focus on the green finance for low carbon technologies. So how does this work? So maybe you can explain a little bit, and also how could this be applied to the heating sectors or the heating inside of the buildings?
Thank you, Professor Xiao, for your questions, and also a great pleasure to join this workshop. Yes, and as you mentioned, that we have been working with the EBRD, the European Revolution and Development Bank, on a very exciting project on promoting their GTS, the Green Technology Schemes, and I think this this will be kind of being a referential or can share some lights on some of the issues that many of the experts has been mentioned today. For example, the high upfront cost for energy efficiency financing and technology financings. So this could be an examples or the best practice from the international side. So just first of all, a little bit introduction on what this GTS technology scheme is. So actually, this is a tool and being developed by the EBRD, the Europe Revolution and Development Bank, as a part of its GEFF scheme, supported by the GEF and Austrian financial departments. And this tool would be initially setting as a kind of a tool for both technology users as well as the financing institutions to issue the financings for technology buyers. And more specifically, it is a very user-friendly online green technology and very user-friendly online shopping tool, and it includes a lot of green technologies all over the world, and the users is over 27 countries all over the world, and most of them are located in the East Europe. For now, there are already over 30,000 technologies already being registered and recognized in this platform. And what would be the working mechanism for this GTS, you may ask? So there's actually 3 parties in this GTS or who would use this GTS tool. So it will be the technology buyers. So the people who would from different countries who would want to buy green technologies, and then the manufacturers, the green technology producers, and also the third one would be the financing institutes. So for example, the technology buyers from different countries, when they log into this shopping tools or this GTS, they will see the high energy efficiency performance technologies appeared according to their countries, and then this tool would show where you can contact these manufacturers, and then what kind of technology indicators this technology would meet, and also this GTS would guarantee that the technologies that's shown on this website would be 30% higher than the minimum energy efficiency performance of this country. So it is very convenient for the for the technology users, and for the manufacturers, it will be also a very exciting tool for them to promote their technologies to different users, and also to the for financing institutes, and also a great tools for them to compare with their peers. What would be the technologies of the same kind? What would be the technology indicators of that of the different technologies? And for the financing institutes, it is also quite convenient for them to lower the financing cost, as this tool automatically have been selecting the high energy efficiency technology for the financiers, so they can automatically choose who can be financing. So this should not be the very first or the very last kind of third-party tool, but the things that but what make it successful, I think, from my personal opinion, it will be, first of all, the EBRD bank has a credit loans for all its for over 145 local financing institutes of all the countries that has been using this GTS tools. And with this credit loans, the financing the financing institutes can use these tools to help them to select the financing bodies. And then secondly, it will be that this GTS, they would hire a third-party consultants, and actually the Carbon Trust is taking this technical role for this GTS in China, and the third-party consultant will help to introduce this tool to both the financing institutes, to the manufacturers, to register their products, and also to make the to promote the market awareness, and to introduce these tools to different parties. And also the third parties would examine whether the technologies who has been registered in this GTS would meet the minimum criteria. And also the final thing would be the indicators, or the threshold for the technologies to be registered in this GTS would be the indicator they choose are actually very common, and it can be applied in different part of the regions. For example, taking the heat pump as an example, it will use the COP efficiency indicators, so it will be applicable to heat pumps of different regions, and then can attract manufacturers of different regions to register their products. And finally, taking back to our topic, how it could promote the heating technologies. Actually, we have been trying to make efforts to help more Chinese products, the heat pumps suppliers in China, to register their products in the tool, and to promote their overseas commercials to other countries. And so far, we have been registered registered, and so far there are over 40 heat pumps has been registered in this tool from the China, who has been rated as a very high efficiency, high energy efficiency performance products. For example, their air source heat pumps and ground source heat pumps. So we're hoping that they could be more such kind of technologies who have the overseas demand, who could use this tool, of course, and also this kind of mechanism or business model can be applied in China as well, to help the financing, both financing institutes and manufacturers, as well as the products users, the buyers, to learn more about the products. Yeah, thanks. Yeah, that's my kind of introduction. Thanks.
Okay, thank you very much, Tina, for this interesting introduction for the platforms or the tools GTS. I have to say that it's quite interesting one, and also huge amount of work in order to establish this kind of platform or tools. And this could use it for connecting for the technical supporters and also end users and the financial support as well. So that's quite interesting, you know, the tools in the future. I think definitely there'll be some people could be quite interested in that, and they could have some contact with you in the future for more detailed discussing. Thank you very much for Tina. So, and I have to speed up a little bit, so we're really behind the schedule. So we go for the topic 3, suitable technical solutions to achieve low carbon resilient and inclusive heating system. So we have 3 experts and panelists going to have this kind of discussions with us. So our first question will go for Mr. Zhao Hengyi. And so are you going to have 我用中文问好还是用英文问好？
Should I speak in Chinese or English? Which way do you prefer? Chinese. Okay, I'll speak in Chinese. So, Secretary General Zhao, heat pump, as mentioned by many experts, has found a lot of applications in northern China. It's also very important in the clean heating program of China. So my question to you is this: Beijing is in the transition of coal to electricity heating. So what role is the heat pump technology in this transition? Besides, what are the co-benefits of heat pumps for low carbon resilient and inclusive heating systems? Okay, first of all, Professor Xia, thank you very much. In the interest of time, I will keep my answers to the point. First of all, in the past 5 to 6 years, starting with 2016 and ending in 2021, in many parts of northern China, including Beijing, a lot of things have been done to replace coal with electricity heating. So by the end of 2021, about 1.08 million rural households have done this transition. The total households are 1.4 million. And we have been trying to investigate the results of these transition, and my organization, the CHPA, is a partner in these investigations. So we know that we have done the transition for 1.08 million households in China, and about 860,000 are using the electricity for these for the heating, and about 5,000, 0.6%, use the heat pump, and also we have 220,000 households, about 20% of the total households that are using the electricity for the heater. So the air source heat pumps have the biggest share here.
the air source heat pumps are the operating cost is about half of the rate of the wall-mounted heat generators. And besides, we've also had surveys, questionnaire surveys about 10,000 households. We try, and the results are quite good. The respondents are very happy about the heat pumps, and so this is one thing we've done. And the second is the low carbon resilient and inclusive heating system. We believe that air source heat pump is very promising as a heating solution, not just in rural northern China where district heating is not available. In fact, in a lot of parts of the countryside, the air source heat pump is being used.
Not only is air source heat pump being widely used in rural China, especially in northern part of the country, consumers are starting to buy the product on their own initiative. Similar trend has also been observed in southern China, because in southern China, about 2 million units are needed for heating in southern China each year, but currently the sales of air source heat pump is just around 200,000. And also, as you can see, the heat from power station is declining. That is why the need for heat pump will continue to increase. So whether it's heating for North China or South China on smaller scale or on large scale, the potential for the application of a heat pump is immense. I'm not just talking about distributed heat pump, but also centralized heat pump. So I think there's a lot of possibilities. But I would also like to add, despite all the encouraging trend, the share has yet to increase because at least in Beijing, our company accounted for 70% in Beijing. But outside of Beijing, air source heat pump is not the biggest, is not the most important product that is used in the retrofitting project, whereas in the past, wall-mounted boilers are considered as the majority of the equipment that is used in the retrofitting project over the past several years or so. Just now I've explained to you while the total number of air source heat pump that has already been used is 2 million. The total number of wall-mounted boilers that is needed, that is already being sold and used is over 10 million. That points to the potential that we can tap into in the future. And hopefully this event also provides us with the platform for us to work in collaboration with the stakeholders to increase the market share of our products like air source heat pump. Okay, thank you very much, Mr. Zhao, for sharing with us a lot of numbers in your presentation that help us better understand how the air source heat pump is used, not just in North China, but also in southern part of the country. The data that you provided with us is very useful, and the case study in Beijing also indicates the huge potential of an air source heat pump, the role that the product can play in retrofitting projects, at least in the southern, in this northern part of the country. Understandably, the percentage of application of air source heat pump in the coal to gas or coal to electricity in its program is still on the lower side, and yet I do believe that there's a potential for the share to grow in the future. Thank you very much, Mr. Zhao. The second question is to Mr. Wang Congfei, Senior Editor from Chinese Association of Refrigeration, because just now a lot of the speakers talk about heating in northern part of the country. I'm sure there are also data that you, Mr. Wang, can share with us. Can you tell us about the application of heat pumps for heating in China? I'm sure you have already gained your share of experience in promoting heat pumps in China. So based on your experience, what would you like to suggest for us to promote heat pumps in the European market? Essentially, this is a question is about helping the heat pumps move beyond the border of China and into the European market. Is there anything that you could like to share that you could share with us? Okay, thank you very much, Mr. Xia, and I am very happy to have this opportunity to be part of this panel discussion. This has been a very informative session. I'm conscious of the time, so I'll be very brief with my answers to your two questions. First of all, over the past recent years, we've seen significant progress in heat pump. In 2021, the sales of a heat pump across the country is around 11 billion RMB, or roughly 1.5 billion euros. But that does not include the equipment used for with waste heat. But with the 1.5 billion euro, here's a breakdown. Hot wind machine accounts for 220 million, and commercial heating 450 million, and also water and ground source heat pump is around 150 million. So despite the fact that we're still going through the COVID pandemic, the growth of the market of a heat pump in 2021 was an impressive 20%. And as has been pointed out, a significant proportion of the growth came from air source heat pump. Apart from heating, the heat pump used for hot water is around 990 million euros. And when it comes to the development of a heat pump industry in China, or what experience can we share with the European colleagues? What can we do to promote heat pumps in the European market? What are the problems that we can foresee? Here are four things I'd like to share with you. First of all, I think the heat pump industry in China has grown significantly in small part thanks to the strong efforts that have been introduced by the Chinese government to fight against air pollution. For instance, the coal electricity initiative that was first introduced in 1915. And also the notification between 1917 and 2019 for that expedited the implementation of a coal to electricity program. And then that was soon followed by the announcement of the Chinese government to achieve carbon peaking and carbon neutrality in the next several decades. And in parallel, there are also several restrictive measures that have been put in place that are against the use of coal. Similarly, I understand the European Union has already been very effective about environmental protection. I understand that there's a lot of volatility that has come with the ongoing Russia-Ukraine conflict. Nevertheless, that trend remains the same for the long run, and I definitely see possibilities for the use of a heat pump as the source of a heating water as opposed to wall-mounted boiler. So that is point number one. And secondly, over the years, we have been on the receiving end of the government subsidy, which has benefited us in many ways. But I am also aware of the adverse impact. For instance, how that may add to the fiscal pressure. As you can imagine, the huge amount of money that is financial resources that is needed in support of the implementation of a coal to electricity program, and I foresee similar programs. Foresee similar problems in the EU. I understand as a result of our Russian-Ukrainian conflict, the energy prices have surged in the local market, but over the long run, the question remains, will there be sufficient fiscal support from the government that sustain the growth of the heat pump market? And another aspect that can play a very important role is standards. I think one of the experts spoke about the importance of harmonization of different energy efficiency standards, which in a way is not in favor of the promotion of the use of a heat pump. I think that problem has been addressed in the European market, and we're also getting there in China. And then I understand now there's a lack of a standard that is specific to heat pump. But now what we are doing here is just to model the evaluate the performance of a heat pump against other standards, which is why I think it is urgent for us to develop standards that are specific for heat pumps, especially in different working conditions. I don't know if there are similar challenges in Europe as well. And then I think there's also technological challenges. I understand in Europe there's a very strict F-gas restrictions, and also and I think one of the challenges that we are confronted with the cold media. And now what we're using here is the conventional or the traditional cold media, which is likely to be replaced in the future. But as to how do we do that, I think more research is needed. And also, I think it won't be possible to paint the vast European territory with just one brush, because across the vast European territory, some area is warmer, some area is colder. So we definitely need a continued research in R&D to support the application of a heat pump across different geographic areas. And then I think it is very important for us to come up with a holistic package of a solution, an area that Europe is doing better than China in. But I've heard that in Europe, there are already a lack of skilled workers who can mount those products, who can install those products with enough proficiency. This is also something that we need to think about in the future. Okay, thank you very much, Mr. Wang, for sharing with us your insights about the promotion of a heat pump in China. What has been achieved, the potential that we can tap into in the future. I think I like the key points that you have raised in particular. For instance, why heat pump has been able to grow so much in China over the years, partly because of policy support, and partly because of the progress that we have made in standards. And just now, our colleague from Germany also talked about the difficulty in the installation of a heat pump, the lack of skilled professionals to do that, how trainings are needed, how cost is high in Europe. The situation probably is a little different in China because we've got a lot of people. But having said that, I definitely think what you have said, Mr. Wang, is will be of a great help to colleagues from Europe. And now I'd like to turn it over to the last but not the least speaker for this session, Zhang Longai from Geely.
Mr. Zhang comes from a very famous home appliance manufacturer that has done a lot in heat pump as well. So what has been the problems in the R&D and also the promotion of the heat pump technology? And are there any common problems in promoting heat pump technology in Chinese and European markets, or what are the differences? So this is to you, Mr. Zhang. Could you give us the perspective from the manufacturer side? Could you hear me? Yes, please continue. Okay, thank you, Professor Xia. I also want to thank the organizers for the invitation. What an honor it is to be here. I have already heard the answers from Secretary General Wang and Secretary General Zhao, very detailed answers and the statistics. And I do feel the same way. The heat demand is now an important source of energy consumption. The data we have now is that we have looked into the water heating, and that's over 40% of the total energy consumption in this sector. And the heat pump is really a major pathway forward. Now, globally, in particular in China, the government is now working to achieve carbon peak and carbon neutrality. We believe that globally and also in Europe, heat pump is in for a big opportunity. We need to find a stable and cost-effective heating solution or system. This is a really big responsibility, and we will do more here. Mr. Zhao and also Mr. Wang have said correctly, China is quite successful in developing this technology. In northern China, for example, the technologies have already been developed for different scenarios in northern China. And in this process, there have been some problems. One problem is that the end users have some concerns or unmet demands about this technology. So from the technical side, this is what I want to share. The first is the reliability of the system and the energy efficiency. Northern China is in the coal to electricity transition. So when the outdoor temperature is down, the heat pump system will be, the heating system will be less, the capacity will be down, and this will affect the user experience. Besides, this coal to electricity transition is likely to move to southern China as well. But here are some new problems. For example, frosting, which could lead to reduced capacity and which would reduce the temperature of the discharge temperature. These are all outstanding challenges here. Currently, we have the floor heating is used wisely, in particular in the river basins of the Yangtze River, but the temperature rise is quite slow. So how could we increase the indoor temperature as quickly as possible with the help of heat pump? So that's one big area of interest for us. And secondly, what about the extreme climate conditions? For example, northern China, the year before the last, saw the coldest winter in 60 years. That will mean the reliability of the heat pump is going to be very important. The heating system is really important for people's life quality. How do we make sure that the system is reliable in the long term, in particular in extreme weather conditions? This will take more than just better design. It will also take better manufacturing technologies, better quality control. Besides, we are using heat pumps not just for hot water supply and also heating for households, but also for industrial purposes. This is where the system needs to do more. So we need core components. For example, the compressors. Can it generate steams or hot water at or above 90 degrees Celsius? That's one big technology challenge for us. Another point was echoed by Secretary General Wang just now. That's about the scenarios of heat pump. It's used more widely than the air conditioner, but the system is more complicated. So when we promote this technology, you would need better designed engineering solutions. You also need better after-sales services to make sure the end users are supported throughout the heating season, and we must be responsive to their needs. As Mr. Wang just said, in Europe, sales of heat pumps are now really exploding. They are surging through the roof, but there is also a problem, that is a lack of skilled professionals to install these devices. It takes a long time to build up the capacity. Besides, there are also other problems here. So in China, we have also identified a similar problem during the coal to electricity transition. So we need the professional capacities building. We also need the better after-sales services. I think Professor Zhang is not muted, so there is some noise. Now, what's different between China and Europe? China has one big market with the consistent standards. So the demands and also the design specifications requirements are pretty much the same. That means we pretty much produce the same devices wherever you go in China. In Europe, I think it was Secretary General Wang who said it varies with the location. Different EU members have their different needs. They probably will they will look for different things in the technology. They also might come up with different stand policies for subsidy or other government incentives. So in different places, we might need tailored technical solutions. Besides, we also have different policies or standards for accessing the government's subsidies and also government certification standards. This is in particular true in Europe. This could probably lead to a greater variety of technologies or products there. And let me give you one example. We have different standards. For example, the NT A700 NF and the iOS. These are all different standards out there. So that is all from me. Well, thank you, General Manager Mr. Zhang. Very good answer and a very exhaustive answer. Pretty much all the engineering problems have been touched upon, and you've also addressed some of the aspects of the promotion. I do agree. Heat pump isn't just a product, it's more of a system, so it needs better design. It also needs better maintenance, better after-sales services, and capacity building. With all of these pieces in place, we could help the heat pump technology succeed better in the market.
Really behind the schedule, so I would like to close for this section 3, this roundtables discussing. And thank you very much for all our distinguished panelists to share us so with fruitful remarks and experience on these sections. And thanks again. And now I would like to pass the floor to Mr. Connor Gask to give the close remark.
Thank you, Mr. Xia, and thank you as well for your excellent moderation in the last session. Some really deep and detailed discussions there where I think hopefully everybody on the call has learned a lot about the different options available. I will be brief as well in the interest of time. So I would just like to forward my thanks again, first of all, to the team at Tsinghua under Director Zhang for all your hard work and support in making this workshop possible. And also a big thanks to the National Development and Reform Commission for your support today, and to the Chinese National Institute of Standardization, CINIS, and Energy Foundation China. Without your support, we wouldn't have been able to make this workshop possible. The main purpose of this workshop, I think, was to create a forum for us to really bring in insights from policy, finance, and technology angles on what we can do to really accelerate decarbonization of the heating systems in the building sector, especially in troubling times with the energy crisis and the climate crisis as well. So I hope that all participants in this call will be able to take away some insights and some ideas on what tools are available both in China, Europe, and elsewhere to address these issues. And one overall takeaway, I think, just to finish off, is that we do have all these options available, but I think as many speakers throughout this event have stressed, it's the combination or the integration of different measures in a way that suits the local context, which will be important for allowing us to meet our goals in the near term, but also in the long term as well. So thank you again to everyone for joining today's webinar. Please look out for more information on outcomes on the webpage, and please as well have a good evening to everybody in China and a good lunch to everyone here in Europe. Thank you.
Thank you. Thank you. Okay, so thank you again. So also I would like to pass for our great thanks to our IEA colleagues to organize such a fruitful workshop. And also I'm looking forward to next time we could have this kind of a face-to-face meeting, and definitely there'll be much better. Even right now, since when they're so very helpful, but face-to-face definitely helps a lot. Thanks again. So I was thinking that could be the closing for today's workshop. Okay, thank you, and thank you, everyone. And good night.
Thank you, everyone. Thank you, Mr.
Thank you. Thank you, Mr. Gask. Bye-bye. Bye-bye. See you next time. Okay.
Thank you, Larry and Zoe. 辛苦了.
No problem.
Have a good evening.
Have a good
nice
evening too.
下面